Hey guys, welcome to Cyber Platter. This is a series on CCSP question and answers. There'll be other parts. This is part 1. The rest of them I will link it in the description box as and when we upload them. This video has around 40 question and answers. This is not just to get familiar with the questions but also to understand the topics. So both the wrong options and the right one will be explained in detail. So let's start.
What cloud concept refers to when the maximum resources can be adjusted to temporary and changing conditions? Reservations, limits, shares, borrowing. So the question asks for the cloud concept that is referring to when the maximum number of resources can be adjusted to temporary and changing conditions. Okay. To understand this question, let's see one of the example setups in cloud. Suppose say we have a server. This is the hardware component. Okay, and then on top of this we have virtualization software. And then we have many VMs set up here. In a multi-tenant situation, these VMs can belong to different customers. This might be of customer 1, this might be of customer 2, and this goes on, okay? And these VMs also need CPU and RAM. How do they get their CPU and RAM? From this host server. Okay, what if this one VM takes up all the CPU and RAM of this host machine? What happens to the other customer VMs, right? This results in a situation called as resource exhaustion. Resource exhaustion is a situation in which an organization is denied resources because the resources are completely consumed by another tenant. Okay? In resource exhaustion is a situation where an organization is denied of resources because the resources are completely being utilized by the other tenants, okay, which are using the same server. Resource exhaustion can be malicious in nature, or sometimes it is not even malicious. It can be accidental, or the other customer is not knowingly utilizing all the resources of the host server. So, to mitigate this risk of resource exhaustion, we have reservations, limits, shares, borrowing, where we can appropriately allocate CPU, RAM, network bandwidth to all the tenants. This is the same concept that is used in host clusters as well. Host clusters are a group of hosts that are connected in a way that they work together and function as a single host. Okay, this can be physically connected or logically connected, and each host resources are pooled together and shared among the cluster. So every host in a host cluster, right, is allocated to perform the same task, which is controlled and managed through a software. One of the advantages of using host cluster is to protect against software or hardware failures, right? If one machine is damaged, it can still work because there is load balancing and parallel processing. And even here for resource sharing, we use concepts like reservations, limits, shares, borrowing. The first option is reservations. This is the minimum resources that is guaranteed for a tenant. Suppose say there is a VM that is on a server, we allocate so much CPU, RAM, or even network bandwidth, minimum number, this is guaranteed for this particular VM. Reservations help protect customers against denial of service attacks due to other resource intensive tenants. The next one is limits. This is actually the opposite of reservations. It is the maximum resources that is guaranteed for a tenant. So that a single tenant will not use a tremendous amount of resources harming the other tenants. When I say tenants, it can be a customer's VM, a host in a host cluster, it can be anything, but we are saying okay, this is the maximum resources that can be allocated. Like for example, 16 GB of RAM is the maximum limit for a VM. And the next concept is shares. This helps us in situations like resource contention. Resource contention occurs when there are too many requests from all the VMs, say suppose, and not enough resources that are available to supply to all of those requests. So in cloud, All the tenants are assigned with a share value. Whichever tenant has the higher share value, right, they receive a larger portion of available resources during that period of resource contention. So the next concept is borrowing. We talked about limits, right, in option B. This is the maximum resources for tenants that is allocated, that is guaranteed. In borrowing, what happens when a limit is allowed to adjust to temporary and changing conditions within the cloud environment, that is referred to as borrow. And that is exactly the answer for our question today, because it is asking about maximum resources that can be adjusted to temporary and changing conditions. So to summarize, reservations is the guaranteed minimum resources for any tenant or a VM or a host in a host cluster. Limits is exactly the opposite of reservations. It is the guaranteed maximum resources for tenants. Reservations help us protect against DOS attacks, denial of service attacks. It protects the customers in that case where the resources are utilized by other resource intensive tenants. Limits help us make sure that a single tenant does not utilize a large amount of resources at the cost of other tenants not getting any resources. Sharing is a prioritization and a weighing system within cloud environment. What happens here, according to the share value, specific applications or customers receive additional resources when requested or when there is resource contention. Borrowing is when a limit is allowed to adjust to temporary and changing conditions within the cloud environment.
Let's go to the next question.
In SaaS, software as a service, who is responsible for application security? Cloud provider, cloud user, cloud provider, and cloud consumer, cloud consumer. To understand this question, we will have to first understand what is software as a service. So let's see how the setup is in cloud, okay? First, let's say there is a server. Okay, this has the memory, motherboard, CPU, right? And then for the connectivity, to connect everything, we need the routers, switches, internet. This is the connectivity part. And then we have storage, which is HDD, SSD, right? And then this is the hardware part. And then we have something called as virtualization software. This is to run like multiple VMs on the same server so that we don't waste space, memory, CPU, right? And then we have the operating system, that is Windows, Linux, and then we have the middleware, and then there is runtime. Runtime can be, if it is web application, it can be IIS. If it is container, it can be Docker. And then we have the application itself, and then there is our data. So it looks like a lot of layers, right? But this can be grouped into three major sections. The hardware and the virtualization software part is called the infrastructure. And then we have runtime, middleware, and OS. This is the software which is required to run the application. It is not the application itself, okay? This is the platform part. And then we have the application and the data, which is our software. Suppose, say, if somebody is taking care of the entire thing from the hardware, so infrastructure is hardware and the virtualization software, right? Including this, and then we have the OS, runtime, middleware, and data application. If everything you're taking care of, then it is the on-prem structure that you're taking care of everything. You're not taking help from cloud service provider. If the hardware and the virtualization software is provided by the cloud provider, okay, and then the consumer is installing the OS, middleware, application, and the data, then it is called as infrastructure as a service. This is the basic model that is provided by any cloud service provider, okay, and it is least expensive also. Mainly, the use cases for infrastructure as a service is for BCDR. It can be used as a warm site where the physical space is provided by the provider and the connectivity as well, and virtualization software and everything that is required to install the application, that is OS, runtime, middleware, and application. Everything is done by the consumer. It can be also used mainly for storage, archiving, backups. Infrastructure as a service is a service where the consumer has the most control over the security of their data. Okay, so when I say least expensive, right, it is least expensive in terms of what you're paying to the provider, but consumer will have to take into consideration that we might need extra staffing, IT staffing, to make this entire thing work, because OS responsibility, middleware, runtime, application, data, everything falls to the consumer. So the physical part of the infrastructure, server, network, storage, is completely the responsibility of the cloud service provider. But with virtualization software, what happens? Because the OS is installed by the consumer and as well as configured by the consumer, this affects the underlying system's security majorly. Okay, that's why what happens, the infrastructure security is shared between the cloud service provider and the cloud consumer in infrastructure as a service model. This part here, whatever the security is shared. Okay, now that we know how infrastructure as a service works, what are the responsibilities of whom? So physical security is completely of cloud service provider, but the virtualization was the infrastructure part. Infrastructure security depends on both consumer and the provider. Now we will talk about platform as a service model. In platform as a service, vendor takes care of the OS part as well. So the vendor, the cloud service provider, is responsible for patching, administrating, and updating the OS as necessary, and keeping security in mind. Okay, and the consumer can install any software that is useful for them and run their application. The common use case for this is software development. It is very much used in software development, as the consumer can test their software in an isolated environment without risking to damage the production. Okay, and also they can test their software across a range of OS platforms. Since not worrying about the OS, they can only concentrate on developing the application. So the entire infrastructure part, right, it is the responsibility of the cloud service provider. Cloud service provider takes care of the infrastructure security completely in platform as a service. But when it comes to the platform, right, some of the configurations are still done by the consumer. So what happens? That becomes the shared responsibility of consumer and the provider. Now let's see what is software as a service model. Okay, in this, for example, Google Docs, Office O365 of Microsoft, your Gmail account, everything is a SaaS solution. In this, the entire platform and infrastructure part is the responsibility of the cloud service provider. Here, the cloud vendor is responsible for administrating, patching, and updating the software, that is the application part as well. What is the cloud consumer responsible for here is to upload and process the data. Okay, but there are some configurations, applications or configurations that are maintained by the consumer. So this part becomes the shared responsibility of the cloud provider and the cloud consumer. Okay, so what do we understand from here is that the physical part, server, network, storage, this is a physical part. This is always the responsibility of the cloud service provider. The data is ultimately the responsibility of the cloud consumer. So if we see the shared responsibility model, right? All the yellow part is the cloud consumer responsibility. Suppose say in infrastructure as a service. Okay. All this GRC, data, application security, platform security, is all the responsibility of cloud consumer. The infrastructure part in infrastructure as a service, that is your clue, is the shared responsibility of both cloud consumer and the cloud provider. These ambiguous, that is the shared areas, right? That is where the risk is the highest, because both the parties are responsible for it, and both the parties should establish a strong separation of duties and responsibilities in order to protect themselves, because both of them have different goals. Like cloud consumer, they want to maximize their computing capabilities and security while minimizing their costs. But the vendor, what do they want? They want to maximize their profits by minimizing what they provide. Okay, this is both in terms of utilities and security. So the shared area should always be mentioned in the SLAs, who should be responsible for what exactly, very specifically. Okay. And in platform as a service, till GRC, data security, application security, all this is cloud consumer responsibility. The platform security becomes the shared responsibility of both consumer and the provider. Okay. In software as a service, the application security becomes the shared responsibility. Okay. And underlying all this is cloud provider, solely the responsibility of cloud provider, that is platform security, infrastructure and physical security in SaaS. So to get back to our question, they are asking application security in a SaaS model. So that becomes the shared responsibility of cloud provider and cloud consumer.
Let's go to the next question.
What refers to the trustworthiness of the data? Option A, sensitivity. Option B, integrity. Option C, confidentiality. Option D, durability. To understand this question, we will have to know the meaning of trustworthiness of the data. Trustworthiness of data means that it is not altered or changed or corrupted through any unauthorized means. So let's see the options. The option A is sensitivity. Sensitivity talks about the classification of the data. Sensitive data is the classified information that must be protected against unauthorized access. So that is not related to the trustworthiness. So that's not our answer. So let's see option B. Option B is data integrity. Data integrity is the accuracy, consistency, completeness, and reliability of data throughout its life cycle. So it means that the data should not be altered or corrupted through unauthorized means. So that can be the answer to this question, but we will also see the other two options. Option C is confidentiality. Data confidentiality is about protecting the data against unauthorized access, unintentional access, and unlawful access as well. Access, disclosure, or theft. It is protecting against all this. So this is not the answer. It doesn't talk about the trustworthiness again. The next option is durability. You might have heard this word a lot when you're using BCDR. So how durable is the data center? Meaning, can it handle the load, withstand any damage? The same logic or concept can be applied to any system. For example, a question which asks, can a server handle the load or withstand the damage, talks about the durability of that server. So this is also not the answer. Like we discussed, integrity is our answer. Integrity is making sure that the data is accurate, consistent, complete, and reliable, which talks about the trustworthiness of that data.
Let's go to the next question.
What involves hiding data in a data set to prevent someone from identifying specific individuals based on other data fields? Option A, obfuscation. Option B, tokenization. Option C, anonymization. Option D, masking. Now let's discuss the question and the options. The first thing that you notice in the question is hiding data. What helps you to hide the data? And also it says that prevent someone from identifying specific individuals based on other data fields. These are the two keywords. Hiding data, all of these options help us to hide data. In cloud or anywhere else, right, hiding the actual data becomes necessary, especially when it is sensitive data. Option A is obfuscation. Obfuscation and masking are the same. Okay, they help making the data less meaningful. It is the process of omitting sensitive information. Okay, they have many techniques to hide or omit the data. For example, the first one is substitution. In substitution, the real data is substituted or replaced or even sometimes appended with some unrelated data. There are two types of substitution. The first one is random substitution and the other one is algorithmic substitution. Okay, in random substitution, the real data is substituted with some random values. For example, if the actual value is welcome, it is substituted with something like W instead of E, I'm going to write a 3. Instead of L, I'm going to write an exclamatory. C instead of O, I will write 0, M, and again 3. This is random substitution. In algorithmic substitution, the real data is replaced based on an algorithm. It is a two-way substitution, okay? What does it mean? If you know the algorithm, the real data can be regenerated from the substituted data. The next method of obfuscation or masking is scrambling. Okay, or you can also call it as shuffling. This is just jumbling the characters in a random order. Okay, for example, say suppose the student ID is 1 2 3 4 5 in production. This can be represented as 4 5 7 9 6, something like that in dev or test environment. Okay, and the next method is deleting. It is also called as nulling. In this, exactly as it says, it is deleting the data. Like for example, the data appears to be empty or blank when an unauthorized person tries to access it. Next method is data masking. In this, what happens? Suppose say that you have your SSN number. SSN number, if you have noticed, is always represented as XXX and then last 4 digits. Okay, the first 5 digits are masked. It is star 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 or XXX, something like that, and only the last 4 digits of the SSN is available. This is called as data masking. Actually, in data masking, there are two different types. One is dynamic data masking and the other is static data masking. In static data masking, a copy of the real data is created and then only the copy is obscured and then used. Okay, this is a very good option when somebody wants to use the production data in a dev or test environment. The next one is dynamic data masking. Here the data is masked in real time. Okay, this is done in real time instead of creating a copy of the actual data. This dynamic data masking is also called as on the fly masking. Suppose say a customer service representative wants to see only the last 4 digits of the SSN. The actual database will have the entire SSN. Okay, but the first 5 digits will be masked from the representative. Now let's talk about option B, tokenization. In tokenization, what happens? A token is generated and that is used to substitute the sensitive data. The token is also stored in a very secure location, like for example, a database. When an unauthorized person wants to see the data, right, only the token is visible to them, not the actual data. This typically uses two databases. Okay, one to store the actual data and the other one to store the tokens. And also remember that it can be used to map back to the original data. Now let's talk about anonymization. Anonymization is also called as data de-identification. Okay, before we understand what is anonymization, we need to understand what are direct and indirect identifiers in a PII. Okay, direct identifiers examples can be like SSN numbers, emails, names, etc. Right? These identifiers immediately reveal the individual's identity. You know, the examples of indirect identifiers are like location, birthplace, what industry, pets, etc. Right? Dates, events, so many things. These indirect identifiers should also be protected, because when many indirect identifiers are put together, they reveal the identity of a specific individual. The act of removing both direct and indirect identifiers is called as anonymization. So this prevents identifying specific individuals based on other data fields as well. So that exactly answers our question, where it is hiding the data and also it is not revealing the identification based on other data fields too. So the answer is anonymization.
Let's go to the next question.
What will protect the data even if a malicious actor gains access to the actual system? Option A, sandboxing. Option B, firewalls. Option C, encryption. Option D, access control. If you want to reread the question, please pause the video here, because next we will discuss the answer. This is one of those questions where you'll have to choose the best answer, right? So what they're asking, there is data and somebody gets access to the system, even then the data needs to be protected. What security measure can we take in such cases? The best answer here is encryption. Suppose, say, a hacker gets access to the system and he gets the data. If the data is encrypted, then even though the person has the data, it becomes impossible to read the data because it is encrypted if he doesn't have the keys. So encryption should be implemented properly. Then if a hacker has access to the data, even then the data is useless to the hacker. Though sandboxing, firewalls, and access control help in preventing the malicious actor gaining access to the system, it does not help a lot when he already has gained the access and he has the data. So encryption is our best bet here.
Let's go to the next question.
What is a cloud carrier? Option A, a person, organization, or entity responsible for making a service available to service consumers. Option B, a person, organization, or entity that maintains a business relationship with and uses service from cloud service providers. Option C, the intermediary that provides connectivity and transport of cloud services between cloud service providers and cloud consumers. Option D, the intermediary that provides business continuity of cloud services between cloud service consumers. So if you need a minute to understand the question and the options, please pause the video here, because next we will be discussing the answer. So let's see the option A here. It says a person, organization, or entity responsible for making a service available to service consumers. That is the role of a cloud service provider. So this is not the answer. Option B is a person, organization, or entity that maintains a business relationship with and uses services from cloud service providers. That is the role of a cloud consumer. So this is not the answer again. Option C is the intermediary that provides connectivity and transport of cloud services between cloud service providers and cloud consumers. That is what a cloud carrier is. So it is an intermediary that is providing connectivity and transport of cloud services between cloud service providers and cloud consumers. Yeah, but we'll see option D as well. So option D is the intermediary that provides business continuity of cloud services between cloud service consumers. So that is not the answer. So according to our discussion, option C is what is called a cloud carrier.
Let's go to the next question.
What cloud concept pertains to the ability to easily remove your IT assets from the cloud provider? Option A, removability. Option B, extraction. Option C, reversibility. Option D, portability. So you can pause the video here for a second if you want to think about it, because next we will be discussing the answers. So let's see what is option A. Option A is removability. This is not an official term or concept in cloud computing, okay? So this is not the answer. So option B, extraction, this is again not the official term or concept in cloud computing, so this cannot be the answer as well. Option C, reversibility. Yes, reversibility is the cloud concept involving the ability for a cloud customer to remove all of its data and IT assets from a cloud provider. Also, processes and agreements would be in place with the cloud service provider that ensure all removals have been completed fully within the agreed upon time frame. So this is the answer, but before we conclude, we'll review option D as well. Option D is portability. Portability refers to the ability to easily move between different cloud providers and not to be locked into a specific one. So portability is not the answer. So we're going with the answer C, that is reversibility.
Let's go to the next question.
Which of the following are attributes of cloud computing? Options: A. Rapid provisioning and slow release of resources. B. Limited access and service provider interaction. C. High cost and unique resources. D. Minimal management effort and shared resources. You can pause the video here, take a minute to think about it if you need to, because next I will be discussing the answers. So here the first option says rapid provisioning and slow release of resources, right? Rapid provisioning, yes, cloud is known for that, but it is not for slow release of resources. It's actually the opposite of this. So we can eliminate option A. Option B is limited access and service provider interaction. Limited service provider interaction, that is true, but limited access, it actually depends on your service model and deployment model. So we will, it might be, but we will just hold on to this question option for now and see the other options. The next one is high cost and unique resources. High cost, actually, if you take public cloud, it is meant to reduce the cost, pay per usage and everything. But if you consider private cloud, maybe it will be costly, but we cannot judge that. So we will also park this question answer for now and see the other option. The last option says minimal management effort and shared resources. This is 100% true with cloud. It is minimal management effort and shared resources when it comes to the cloud environment. And also, if you know the NIST definition for cloud computing, it does talk about shared resources and minimal management effort. So to quote NIST definition of cloud computing, it says cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. So if you know the NIST definition, you're 100% sure that option D is your answer.
Let's go to the next question.
How is single loss expectancy SLE calculated? Option A, asset value into annualized loss expectancy, asset value into annualized rate of occurrence, asset value into exposure factor, asset value into return on investment. We will not just discuss what is the answer for this, we'll also see what is the use of SLE, how it is calculated, where it is used, and what is the purpose, right? Single loss expectancy is calculated during the quantitative method of risk assessment. Risk analysis has different methods. We will talk about this in a minute. So, what is risk analysis? Right, risk analysis helps us to measure the probability and the consequences of any known risk. So the goals of risk analysis, actually there are four goals of risk analysis. First is to identify the organizational assets and their values, and then to identify the vulnerabilities and the threats, and then to measure the probability and the impact of any risk, and the fourth one is to balance the cost of countermeasure and the impact of threats, right? There are different methodologies to carry out risk assessment, but today we will discuss about NIST SP 830. So what happens in any organization or most of the organizations, right? They take a standard and then they customize it according to their needs. So now let's see the steps involved in NIST SP 830. This is Risk Management Guide for Information Technology Systems. Okay. So the first step in here is to define the scope. That is, what are the assets that needs to be considered for this particular assessment, or everything under the organization belt is considered. What is the value of these assets? What is the criticality and the sensitivity of these? What are the functions? What needs to be present for the organization to keep running? So it can be hardware, software, system interfaces, data and information, people, system mission, etc. Right? The next step is to identify the potential threats. Threats can be sometimes intentional or unintentional as well. There are different types of threats. For example, in natural, you can have floods, earthquakes, landslides, tornadoes. In humans, you can have intentional and unintentional. Like for unintentional acts can be, errors, carelessness, accident. Deliberate actions can be attacks, unauthorized access, physical theft or damage, right? Environmental, there is again environmental threat as well, like pollution, chemicals, power failure, etc. So what we do here, we review the historical incidents and also collect data from intelligence agencies, government, to generate a list, and this list is finally tailored according to the individual organization. The next step is to identify the vulnerabilities. This can be technical vulnerabilities or non-technical vulnerabilities. Technical vulnerabilities can be the CVE numbers that we get. Non-technical can be incomplete policy or conflicting policies. So here we take into consideration reports from the prior risk assessments, any audit recommendations that is provided, security requirements, or security test results, and try to create a list of potential vulnerabilities. The next step is risk assessment. So we'll talk in a little bit about risk assessment. Just know for now that there are different types of risk assessments: qualitative, quantitative, and hybrid. Hybrid is the combination of qualitative and quantitative risk assessment. So once we have the likelihood and the impact of risk, right, the next step is risk response. So in risk response, this is also known as risk treatment. There are many methods how you address a risk. The first one here is to mitigate the risk. This is where you reduce the risk, like implement cost effective controls. The next one is to accept the risk. Here, after careful consideration, right, the organization decides to live with it. I mean, without implementing any countermeasures. Okay, most likely here, whatever the risks that have low likelihood or low impact, right, those are the candidates for risk acceptance. The next one is to transfer the risk. Here what happens, it is given to somebody else. Like for example, you're buying an insurance or getting a service level agreement. So what you're doing, you're transferring the risk. Next one is risk avoidance. This involves changing the activity that is causing the risk. Suppose say you want to do some activity A, which is like very high risk. So what you do, you completely terminate this activity and go to activity B, which has less risk. And the next option is to ignore or reject the risk. This is not at all an acceptable option. It is not a valid option, because here the organization just pretends that the risk is not existing. In accept, there is a careful consideration. So they see like, okay, if I implement the countermeasures, I'm going to spend more than actually accepting the risk. Then they make a good evaluation, then accept the risk. But in ignore or reject, they completely reject it and pretend that the risk never existed. So it is not a valid option. So there are three things that you need to know: total risk, residual risk, and secondary risk. Always remember that total risk can never be completely eliminated. It cannot be 100% mitigated. Okay, total risk is any risk that exists before the controls are implemented. This is calculated using threats into vulnerability into asset value. Residual risk is the risk after the countermeasures or the safeguards are implemented. So residual risk is equal to total risk into control gap. It is also calculated by total risk minus the countermeasures. And there is secondary risk. This is the risk event that comes as a result of another risk response. Suppose say you implement a countermeasure and that countermeasure is causing another risk. So remember that the control gap is the difference between the total risk and the residual risk. It is the amount of risk that is reduced by implementing countermeasures or safeguards. Again, please remember that risk can never be completely eliminated. Okay, going back, we did risk response, and after this we have to do something called as countermeasure selection. That is, you have to select a safeguard. It should be cost effective and it should also be appropriate for that risk. While calculating safeguard costs, you should consider how much it costs for the purchase, development, and licensing, how much it costs for the implementation, or if there is any customization that is required, cost of annual operation, maintenance, administration, if there are any annual repairs, upgrades, productivity improvement or loss that happens, changes to the environment. Whenever there is any change, do we have to spend again? Cost of testing and evaluation. So the output of this step would be to identify the controls that could reduce the identified risks or to provide alternate solutions to mitigate the risk. Once all this is done, then we come to documentation. The results are documented. The results of the risk assessment are documented in an official report, or it's like a briefing, so that you provide it to the senior management to make their decisions on policy, procedure, budget, and system operation and management changes. Now that we know how risk assessment works, that is NIST SP 830, we will talk about risk assessment, the step we missed because it's a little bigger one, so I kept it at the last. Since now we'll see how actually our answer to the question SLE is calculated, what are the steps in risk assessment, what are the types. So in risk assessment, there are three types: qualitative, quantitative, and hybrid. It's more of opinion or scenario based analysis. Okay, it does not quantify the data, it does not use any calculations. So the ratings are given, say suppose the likelihood and impact, right? They're just told, okay, this is going to be high, medium, or low. There is no fixed value to it, like it doesn't quantify, there is no money related, there are no numbers in qualitative risk analysis. Some of the techniques that we use in qualitative risk analysis are brainstorming. It's like a group discussion. You get a number of people and you throw in creative ideas and come up with a process and with a value. And then storyboarding. Processes are tuned into panels of images depicting the process in this. Okay, there are focus groups, we have panels of users in this, there are surveys, there are questionnaires which are provided, checklists, one-on-one meetings, there are interviews. And one more thing that you want to remember is the Delphi method here. This is a technique where it's a group discussion method where each group member can communicate anonymously with each other. The purpose of this is to promote honest and uninfluenced responses from all participants. Okay. The next one is the quantitative risk analysis. This is a more mature process. Here we have monetary values that are assigned, and this is very objective in nature. Qualitative is very subjective. Okay, there are many steps in quantitative risk analysis finally to come to a numeric or monetary value, right? The first one is to assign an asset value. So the asset value can depend on the criticality of that asset to the organization, acquisition or development costs. What if we have to replace that asset value? What is the maintenance and production costs? Productivity and operational losses or impact if at all this asset is unavailable. What is the value of this asset that is provided by the owner? What is the outside valuation, that is the fair market value, that is the price others are willing to pay for that asset? And liability, what if the asset is compromised, what should be, how much loss are we in? Then the next step is to calculate the exposure factor. It is the percentage of value lost in a typical incident. This ranges from 0 to 1. Suppose say the exposure factor is 25%, then the value is 0.25. Okay, the next thing that we calculate is single loss expectancy. Single loss expectancy is the cost associated with a single realized risk against a specific asset. That is, it is the dollar value lost when an asset is successfully attacked. So SLE is calculated using asset value into exposure factor. That is also the answer to this question, but we will learn more about this because this might not be the only question. There might be other things in this area. The next item we will calculate is ARO. ARO is the frequency with which a specific threat will occur within a single year. Suppose say if a threat, like for example earthquake, occurs once in 100 years, okay, then the value of ARO is 0.01. The next item here that we will calculate is ALE. ALE is the annualized loss expectancy, that is potential yearly cost of all instances of a specified threat. So ALE is calculated using SLE into ARO. The next step here is the cost benefit analysis of the countermeasure. For this, we will have to calculate the value of the safeguard. This is ALE before the safeguard minus ALE after the safeguard, and then the cost of the countermeasure. Okay, so this gives us the value of the safeguard to the company. If this value ALE1, that is the ALE before safeguard minus ALE after safeguard minus cost of countermeasure is a negative value, then the safeguard is not a financially responsible choice, but it might be a legal responsibility and prudent due care. Remember that the cost of the countermeasure should be less than the cost of the value of the asset. The cost of the countermeasure should also be less than the benefit that we get from the countermeasure. And the third method of risk analysis, that is the hybrid method, is the combination of qualitative and quantitative risk analysis. So to recap, what did we learn today? We learned about risk assessment. Risk analysis, what is the goal of risk analysis? You get the asset value, we get identify the vulnerabilities and the threats, we get the impact of the risk likelihood as well, and how to balance the cost of countermeasure and the impact of threats. We talked about the steps in NIST SP 830, that is for risk management. First, we identify the scope, that is we get the assets and the value of the assets. Then we identify the threats, natural, human and environmental threats. Then we find out the vulnerabilities, both technical and non-technical vulnerabilities. Then we do the risk assessment. In risk assessment, we have quantitative and qualitative and hybrid as well. And once the risk assessment is done, we get into risk response. In risk response, we have mitigate. This is to reduce the risk. Accept is to do the analysis and then accept the risk. Transfer is insurance or SLA. Avoidance is to not do the activity at all, just to terminate the activity. Ignore or reject is not a valid option because there is no analysis done and the organization pretends to have no risk at all. And then remember that total risk can never be completely eliminated. total risk is equal to threats into vulnerability into asset value. Residual risk is the risk that is left after the countermeasure is implemented. It is total risk into control gap. It is also total risk minus the countermeasure. Secondary risk is the risk that occurs one because of the countermeasure that is implemented. And then we identify the countermeasure, what needs to be done. It's like preventative, deterrent, all the countermeasures, and then we document all the results so that it can be presented to the senior management so that they can make their decisions on policy, procedure, budget, and management changes. So when we talk about risk assessment, qualitative risk assessment is a subjective option. It just assigns values, likelihood and risk, likelihood and impact, saying high, medium, low, or extreme. And it is there are many qualitative techniques that we can use. For example, interviews, group discussions, Delphi method, where in the group discussion everybody can share their ideas anonymously. Quantitative risk assessment is a very mature process. It assigns monetary or numeric values to the risk. It is also very objective. In quantitative, first we identify the asset value and then we find out what is the exposure factor. Exposure factor is always percentage value, that is percentage of value lost in a typical incident. This ranges from 0 to 1. And then we calculate single loss expectancy, that is asset value into exposure factor. It is the dollar value lost when an asset is successfully attacked. Then we calculate ARO, that is annualized rate of occurrence, that is the frequency with which a specific threat will occur within a single year. It is also known as probability determination. And then we have ALE, annualized loss expectancy. It is the possible yearly cost of all instances of a specific threat against one specific asset, and it is calculated using SLE into ARO. Then we have cost benefit analysis. The value of the safeguard to the organization is calculated using ALE, that is ALE before safeguard, ALE after safeguard minus the cost of countermeasure. This cost of countermeasure is annual cost of countermeasure. Okay, if this result is negative, then the safeguard is not a financially good option, but we might want to consider legal responsibility and prudent care and implement the countermeasure. Remember that the cost of countermeasure should be less than the asset value, and it should also be less than the benefit that we get from the countermeasure. Now the answer to this question might seem very easy. So single loss expectancy, SLE, is calculated by this formula, asset value into exposure factor.
Let's go to the next question.
What level of FIPS 142 provides protection against environment failures? Option A 1, option B 2, option B 3, option D 4. To understand this question, let's see what is FIPS 142 and its levels. FIPS stands for Federal Information Processing Standard. It provides the requirements and standards for cryptography modules. It covers both hardware and software components for cloud and as well as traditional computing environments. It aids in the protection of digitally stored, unclassified yet sensitive information. It was developed by NIST for use in computer systems by non-military American government agencies and government contractors. It needs to be validated by independent third-party laboratories. There are 4 security levels in FIPS. Let's see what are those one by one. The first one is level 1. It provides the lowest security. It allows the use of an unevaluated operating system. That is, it allows the software and firmware components of a cryptographic module to be executed on a general purpose computing system that is using an unevaluated operating systems. The other levels of FIPS, right, they use operating system that are evaluated, that are tested, that uses common criteria, EAL levels. Okay, level 1 requires no specific physical security beyond the basic requirement for production grade components. For example, a PC encryption board is considered to be level 1 FIPS. Level 2. Level 2 requires common criteria EAL level 2 software and firmware. It requires tamper evidence requirements like, for example, seals, coatings, pick resistant locks. The goal of this level is to provide visible assurance of a device's integrity. Next is level 3. Level 3 has tamper resistant controls. It uses common criteria EAL level 3 software and firmware or higher than that. Level 4 uses EAL 4 software and firmware of common criteria. It provides strict physical security. There needs to be immediate zeroization of plain text upon any tamper detection. It uses tamper protection envelope and tamper response. It also protects a cryptographic module against a security compromise due to environmental conditions or fluctuations. That is, it provides protection against environmental failures. Now that we know what is FIPS and the levels, answering this question should be easy. To read the question again, what level of FIPS 142 provides protection against environment failures? The answer is level 4 of FIPS, which provides protection against environmental conditions or fluctuations.
Let's go to the next question.
Which of the following cannot be used as an application threat model? ATASM, DREAD, PASTA, SAFECode. Let's see what is threat modeling. It is a process to identify potential threats, vulnerabilities, or the absence of appropriate safeguards, that is countermeasures, right? It helps us to identify the weaknesses in an application and the potential, ingress, egress points and the actors involved. All this is done before it is introduced to production. Threat modeling basically answers questions like where is the application most vulnerable to get attacked? What are the most relevant threats? What needs to be done to safeguard against these threats? There are many threat modeling methodologies, okay? Let's see the first threat modeling methodology, that is Stride. Stride helps us categorize known threats according to the kinds of exploits that are used. Stride is a mnemonic. S stands for spoofing. That means it checks if a user can assume the identity of a valid user or a subject. T stands for tampering. Here it checks can an attacker alter data. R stands for repudiation. Can the user deny their action? That is what is checked. Next is information disclosure, which stands for I. Can the attacker obtain the information without any authorization? D stands for denial of service, that is DOS attack. Can the attacker overload a system to deny legitimate access? E stands for elevation of privilege, that checks can the attacker gain a privilege level above what is permitted. All of these threats, right, they are a violation of a desirable property for a system. Like spoofing is a violation of authenticity, that is the origin of, like, say, a message or a document. Then tampering is violation of integrity. Repudiation is a violation of non-repudiation. Information disclosure is a violation of confidentiality. Denial of service is a violation of availability. Elevation of privilege is a violation of authorization, that once it gets the access, it can violate CIA, that is confidentiality, integrity, or availability. Next, we'll see what is PASTA. This is also a threat model. It stands for Process for Attack Simulation and Threat Analysis. There are 7 stages of PASTA threat modeling. The first one is to define your business objectives. Here we focus on what is important to our business, understand the objectives of each application or product. Then the second step is to define the technical scope of assets and components. That is, we are trying to understand the attack surface and to create a picture of what needs to be protected. Like, for example, how are they configured? What are the dependencies they have on other applications, internal or external applications? The next step is application factoring and to identify application controls, that is application decomposition. That is, here we map the relationship between different components of the application. We identify the users, their roles and permissions, what are the assets being used, the data, the services, hardware, and software. Next is threat analysis based on threat intelligence. Usually, we research and find out what are the threats that can affect the application based on the previous data as well that has affected the applications or assets in your organization. So we do the threat analysis. Next is vulnerability analysis. We try to map which weaknesses will break under what threats. Then the sixth step is to analyze and model attacks. In this stage, we try to mimic the attacks that could exploit any, weaknesses or vulnerabilities that are identified. The last and final step is risk or impact analysis and develop the countermeasures. The next threat model that we'll see is DREAD. DREAD focuses on a quantitative value for assessing risks and threats. With a quantitative value, it can be compared with other systems and even with itself over time. Okay. DREAD is also a mnemonic for risk rating security threats, and it is rated from 1 to 10. Okay. D stands for damage. How bad would an attack be? R stands for reproducibility. How easy is it to reproduce the attack? Then we have exploitability. How much work is it to launch the attack? Affected users. How many people will be impacted by this? Discoverability. How easy is it to discover the threat? Now say I'll rate all of this. Suppose say damage is 5, reproducibility is 2, exploitability 9, affected users I'll give an 8, discoverability I'll give a 5. To calculate the risk dread, we have to add all these values, that is 5 plus 2 plus 9 plus 8 plus 5, and divided by 5. Next we have ATASM threat modeling methodology. A stands for architecture, T stands for threats, AS stands for attack surfaces, and M stands for mitigations. This threat modeling helps us to highlight the importance of structural understanding of a system for the purpose of threat modeling. There are mainly 4 steps in this threat model. The first one is to understand the architecture, that is all the components of the architecture, understand every communication flow and any valuable data that is moved and stored. The second step is to list all the possible threat agents, find out what are their ultimate goals, and also list the typical attack methods of these threat agents, and also to list the system level objectives of these threat agents using their attack methods. The third step is related to the attack surfaces. Here we decompose the architecture and expose every possible attack surface, apply the attack methods for expected objectives, and then we apply the attack methods. Also, we filter out threat agents who have no attack surfaces exposed to their typical methods. Then we have the last step as mitigation. Here we list all the existing security controls for each attack surface, and then we filter out the attack surface for which there is sufficient existing protection. And also we apply new security controls to the set of attack services for which there isn't any sufficient mitigation. We try to build defense in depth in this step, okay? And this is about the threat modeling part. There is also another option called SAFECode in the question, right? SAFECode stands for Software Assurance Forum for Excellence in Code. This is an organization that provides a global industry forum where all the business leaders and technical experts can come together to exchange their insights and ideas. This is mainly to create, improve, and promote scalable and effective software security programs. SafeCode publishes a guide called SafeCode Fundamental Practices for Secure Software Development in an effort to help organizations to initiate or improve their own software assurance programs and encourage the industry-wide adoption of fundamental secure development practices. SafeCode focuses on fundamental practices to reflect, current best practices, new technical considerations, and a successful secure software development lifecycle, that is SDLC. It also focuses on application security control, how to come up with a secure design. It talks about threat modeling, also talks about, secure coding practices. It talks about security risk inherent in the use of third-party components. It focuses on the findings, security findings, how to manage them, vulnerability response and disclosure. It also talks about, testing and validation. It also focuses on planning the implementation and deployment of secure development practices. Now that we know what is a threat model, what are the methodologies used in threat modeling, and what are all the options of the question that is given, let's go back to the question. Option A is ATASM. Yes, we saw that it is a threat model which focuses on the structural understanding, that is the architectural understanding. Option B is DREAD. We saw what are the mnemonics of DREAD and how it helps in threat modeling. Next one is PASTA. We saw the 7 steps in PASTA that is used for threat modeling. So all these are threat models. Option D is SAFECode. This is not a threat model. It is used for secure coding practices. So the answer to today's question is SAFECode.
Let's go to the next question.
Match the characteristics with the right storage cluster type. That is, we have to match performance scaling, flexibility, independent, restrictive design parameters with tightly coupled storage cluster and loosely coupled storage cluster. Let's see what is a storage cluster. Cluster, like the name says, it is a pool of storage devices or servers working together. In storage clusters, the workload is distributed to each server in the cluster. It manages the transfer of workloads between the servers, and it also provides dynamic system availability. What is dynamic system availability? Suppose, say, you have your web server hosted on a DC1, and it is connected to a storage cluster. It fails, and the failover is to data center 2. The web server is now in data center 2. There is no reconfiguration required, and these both data centers can be connected to the same storage cluster. That is dynamic system availability. And also, storage clusters can provide access to any file on any server, I mean the servers in the cluster, regardless of the physical location of those files. The goals of storage clusters is to provide or meet SLAs, that is, provide high availability. It also provides increased performance, capacity, and reliability. Storage clusters should be configured in a way to provide customer data isolation and to provide secure storage. There are two types of storage clusters. First one is the tightly coupled cluster, and the other one is the loosely coupled storage cluster. All the devices or servers in tightly coupled cluster are connected to a shared physical backplane. So all of these are directly connected to each other, all these servers or devices, okay? Each node or server is aware of the others in the cluster, and also they have the same policies and rule sets. Tightly coupled clusters most usually have restrictive design parameters, like for example, all the devices should be from the same vendor for them to function properly. The performance in tightly coupled cluster increases with the number of nodes. So you keep adding more nodes, the performance keeps increasing. So the performance scales with the number of nodes in tightly coupled architecture. Tightly coupled clusters also strive to provide fault tolerance. So initially, when we were discussing goals, that we said high availability is provided by both loose and tight coupled ones, right? But tightly coupled architecture also provides fault tolerance, at least theoretically. So any device that is providing fault tolerance by default provides high availability as well. Like for say, high availability is providing 99.99% of uptime. That means you're expecting the system to go down, but it recovers really fast. But in fault tolerance, even if there is any fault in the components, the system will still continue to work. It's almost like, providing 100% uptime. Now let's see loosely coupled architecture. This architecture is more flexible compared to the tight coupled cluster. Here, the devices or servers are independent of each other. So these nodes are only logically connected and don't share the same physical framework, right? Like how we show in this picture here, it has separate physical frameworks, every node. So they are only distantly physically related through some communication media. Here, the performance does not necessarily scale with the number of storage devices or nodes. The maximum performance and capacity are limited to the performance of the node where the data resides or the data is housed. Loosely coupled cluster is relatively inexpensive. Now that we know the characteristics of tightly coupled and loosely coupled cluster, let's go back to our question. Match the characteristics with the right storage cluster type. Performance scaling, it is related to tightly coupled architecture because the performance scales with the number of nodes in the cluster. The number of nodes increases, the performance increases with tightly coupled, whereas in loosely coupled, the maximum performance is limited by the maximum performance of the node where the data is. Then flexibility, loosely coupled storage is more flexible than tightly coupled one. Independent, again loosely coupled storage, the devices are independent of each other. In tightly coupled, they are very dependent on each other. Restrictive design parameters, that is related to tightly coupled storage cluster.
Let's go to the next question.
Which of the following cryptographic protocol is commonly used to secure web communication by providing encryption and authentication? Option A, IPsec, Internet Protocol Security. Option B, SSL/TLS, Secure Sockets Layer, Transport Layer Security. Option C, SSH, Secure Shell. Option D, SNMP v3, Simple Network Management Protocol version 3. Pause the video here and try to answer the question. Okay. All right. So the question is asking about which protocol is used for secure web communication. Before answering this, let's see all the options and learn those terminologies. Option A is IPsec. IPsec stands for Internet Protocol Security. It operates at the network layer, that is layer 3 of the OSI model, and is primarily used to secure IP-based communication between devices, ensuring the confidentiality, integrity, and authenticity of data transmitted over the internet or other untrusted networks. IPsec can be implemented in two main modes. First one is the transport mode. In transport mode, only the payload means the actual data of the IP packet is encrypted while leaving the original IP header intact. This mode is typically used for securing communication between two endpoints, such as between a client and a server. We have another mode which is called the tunnel mode. In tunnel mode, the entire IP packet, including the original IP header, is encapsulated and encrypted within a new IP packet. This mode is often used to create secure VPN tunnels between two network gateways, providing secure communication between different networks. IPsec uses various cryptographic algorithms for encryption, such as AES, Triple S, or Blowfish, and for authentication, it uses algorithms such as HMAC. HMAC stands for Hash-Based Message Authentication Code. IPsec is a crucial component of VPNs, allowing organizations to securely connect remote offices, mobile users, and telecommuters to their corporate network over the internet. Now that we know what is IPsec, let's see the second option, SSL/TLS. SSL stands for Secure Sockets Layer and TLS stands for Transport Layer Security. These are cryptographic protocols designed to provide secure communication over a computer network, especially for web browsing. SSL was first developed by Netscape. It was developed in the 1990s, and TLS is the successor, and TLS offers stronger security enhancements. The SSL TLS handshake process establishes a secure communication between the client and the server. The client is usually a web browser, and the server is usually a web server hosting a website. During this handshake process, the client and server negotiate the encryption algorithms and the cryptographic keys they will use for securing the communication. Once the secure communication is established, all data exchanged between the client and server, including HTTP requests and responses, are encrypted and protected from eavesdropping and tampering. SSL-TLS uses various cryptographic algorithms such as RSA for key exchange and authentication, and symmetric encryption algorithms like AES and RC4 for data encryption. It is widely used to secure online transactions, login credentials, and any sensitive data transmitted over the internet, helping to protect against eavesdropping and unauthorized access. Now let's see what is SSH. SSH stands for Secure Shell. It is used to establish secure remote shell sessions and perform secure file transfers between computers over an insecure network such as the internet. SSH provides a secure channel for accessing and managing remote devices, especially servers and networking equipment. SSH uses public key cryptography. This is used for authentication, allowing users to generate a key pair. A key pair consists of a private key, and this private key stays on the user's computer, and a corresponding public key. This is uploaded to the remote server. When a user attempts to establish an SSH connection, the server verifies the user's authenticity using the public key. Once authenticated, the connection is encrypted to protect the data exchanged during the remote session. SSH can also be used for secure file transfer using the SCP, that is Secure Copy, or SFTP, that is Secure File Transfer Protocol subsystems, allowing users to transfer files securely between their local computer and the remote server. Now let's see the last option, that is SNMP version 3. SNMP stands for Simple Network Management Protocol. Like the name suggests, SNMP is a protocol used for network management and monitoring. SNMP allows network administrators to monitor network devices, collect performance data, and manage network configurations remotely. SNMP version 3 is the secure version of SNMP, addressing security vulnerabilities present in the earlier versions, SNMP version 1 and SNMP version 2. SNMP version 3 introduced security features to protect against unauthorized access and ensure the integrity and privacy of management information. It enhances SNMP security through authentication and encryption. First, let's talk about authentication. SNMP version 3 provides authentication to ensure that the messages exchanged between SNMP devices are legit and from authorized sources. It uses HMAC with cryptographic hashes like MD5 or SHA to achieve authentication. HMAC stands for hash-based message authentication code. Now coming to the next feature, encryption. SNMP v3 provides privacy and data encryption to prevent eavesdropping and unauthorized access to management information. It encrypts the SNMP message using symmetric encryption algorithms like DDoS or AES. So because of these security enhancements introduced in SNMP version 3, network administrators can confidently use SNMP for network management tasks without worrying about data confidentiality or integrity that were prevalent in the earlier versions. So in conclusion, all these cryptographic protocols, right, play critical roles in securing various aspects of network communication. Let's go back to our question now. Here the question is asking about which protocol provides secure web communication. Option A is IPsec. IPsec secures network communication at the IP or network layer and is commonly used for VPNs and securing router to router communication. So this is not the choice. Second option, SSL TLS. This secures web communication by encrypting and authenticating data exchanged between clients and servers, commonly used in HTTPS to protect data during online transaction. So this is used for web communication, commonly used for web communication. Okay, so this might be our answer, but let's see the other two options as well. SSH provides remote shell access and file transfer between computers over an insecure network like the internet, commonly used by system administrators for remote management. So this is not the answer here because we are talking about web communication. Next option is SNMP3. SNMP version 3 secures network management and monitoring by providing authentication and encryption for management data. This ensures the integrity and privacy of SNMP communication, but it is not related to the web communication. So this is also not our option. So the answer is SSL TLS, that is commonly used to secure web communication.
Let's go to the next question.
Which of the following encryption techniques is commonly used to protect data confidentiality in cloud? Option A, WEP, Wired Equivalent Privacy. Option B, AES, Advanced Encryption Standard. Option C, DES, Data Encryption Standard. Option D, RSA. You can pause the video here and give it a try. Okay, so this question is about data confidentiality. How is the data confidentiality achieved, which is the commonly used algorithm, right? Let's see what is option A first. WEP, that is Wired Equivalent Privacy. It is an outdated security protocol that is used to secure wireless computer networks. It was part of the IEEE 802.11 standard, also known as Wi-Fi. The primary purpose of this protocol was to provide a level of confidentiality and privacy for wireless communications, attempting to make the security of wireless networks comparable to that of traditional wired networks. It was introduced in 1997 when this happened. However, over time, significant vulnerabilities were discovered in this protocol, making it highly insecure. So, web is highly insecure. The weakness in web encryption allowed attackers to easily crack the encryption keys and gain unauthorized access to the wireless network. Let's see some of the issues with this protocol. First one is weak encryption. Web uses relatively short encryption key 40 or 104 bits, making it susceptible to brute force attacks. Another weakness is key management flaws. Web uses a static encryption key. That means the key is not changed frequently. This lack of key rotation makes it easier for attackers to capture enough data packets to crack the key. Another weakness is initialization vector reuse. Web uses a small initialization vector that is reused, leading to pattern recognition and further weakening the encryption. As a result of these serious security flaws, web is no longer considered a secure encryption method and its usage has been strongly discouraged. It has been superseded by more secure protocols such as WPA and WPA2. WPA stands for Wi-Fi Protected Access. These protocols use stronger encryption algorithms and better security practices to protect wireless communications. WPA2 is currently the most widely used and accepted security protocol for securing Wi-Fi networks. Okay, so now we know about option A. Let's see what is option B. AES stands for Advanced Encryption Standard. It is a widely used symmetric encryption algorithm. AES was selected by the US National Institute of Standards and Technology, that is NIST. It was selected in 2001 to replace the older DES algorithm, that is Data Encryption Standard. It was replaced as the standard encryption algorithm for securing sensitive data. AES operates on fixed size blocks of data. This fixed size is 128 bits. and supports key sizes of 128, 192, and 256 bits. It is a strong and versatile encryption algorithm. It is used to protect data confidentiality, ensuring that unauthorized individuals cannot read or understand the encrypted information without the correct decryption key. The AES algorithm consists of several rounds of substitution, permutation, and mixing operations, which are repeated a specific number of times based on the key size. The complexity of these operations and the size of the key contribute to the strength of the encryption. Due to its security and efficiency, AES is commonly used in various security protocols and applications such as securing data transmissions over network, encrypting files, and protecting sensitive information in databases and storage systems. It is also a foundational component of many security standards, including those used in secure communication protocols like TLS, Transport Layer Security, and IPsec, Internet Protocol Security. Okay, now let's see what is DES, that is option C. DES stands for Data Encryption Standard. It is an encryption algorithm that was widely used for securing sensitive data in the past. It was developed in the early 1970s by IBM and adopted by the US government as an official encryption standard in 1977. This is a symmetric encryption algorithm, meaning the same key is used for both encryption and decryption. AES is also the same. It is a symmetric encryption algorithm, meaning the same key is used for both encryption and decryption. DAS operates on fixed sized block of data, that is encrypting or decrypting 64-bit blocks at a time. The original DES uses a 56-bit encryption key. However, due to advances in computing power and cryptographic techniques, this key length was considered insufficiently secure against modern attacks. DES was once considered strong and secure, but over time vulnerabilities were discovered and its key length became inadequate to resist brute force attacks. We mentioned before that AES was introduced to replace DES, right? There is also another algorithm called triple DES. This was also used to replace DES. Triple DES applies DES algorithm 3 times in sequence with 2 or more different keys, effectively providing a key length of 112 or 168 bits. Triple DES was considered a temporary solution while transitioning to stronger encryption methods. As of today, DES is considered obsolete and not recommended for use in modern cryptographic applications. So now we know about DES algorithm, that it is obsolete and it's not used anymore. Now let's next see the option RSA. What is RSA? That is our last option. RSA is an asymmetric encryption algorithm. It is widely used for securing key exchange, digital signature, and other cryptographic applications. So it is an asymmetric encryption. That means it uses a pair of keys, a public key and a private key. The public key is used for encryption while the private key is used for decryption. To use RSA, a user generates a public-private key pair. This is like in any other asymmetric encryption. The public key can be shared openly with anyone while the private key is kept secret and known only to the owner. While RSA is a powerful and widely used algorithm, it is relatively slow compared to symmetric encryption algorithms like AES. As a result, it is commonly used for tasks that require secure key exchange, digital signatures, and securing small amounts of data such as encryption keys for symmetric encryption algorithms. So now that we know all the 4 options, let's go back to our question. Okay, here the question is, which is commonly used to protect data confidentiality in cloud? So option A, that is web, like we discussed, is an outdated and weak encryption protocol that was primarily used for securing wireless networks. It is vulnerable to various attacks and is not considered secure for modern applications. So this is not our option. Option B is AES, Advanced Encryption Standard. This is commonly used to protect data confidentiality in cloud and various other security applications. It is a symmetric encryption algorithm known for its high security, efficiency, and widespread adoption. AES has become the de facto standard for encrypting sensitive data due to its strong cryptographic properties. So B is the correct answer, but let's also see the other two options just to make sure. Option C is DES. DES was once a widely used symmetric encryption algorithm, but it is now considered weak and insecure due to its short key length. Option D, RSA, commonly used for key exchange, digital signatures. While it has its applications, it is not primarily used for data encryption in cloud, where symmetric encryption algorithms like AES are more efficient and commonly employed. So this is not the answer to. For data confidentiality, the answer is option B, AES.
Let's go to the next question.
Which of the following security controls is most effective in preventing privilege escalation attacks? Option A, RBAC, role based access control. Option B, intrusion detection system, IDS. Option C, mandatory access control. Option D, security information and event management, that is a SIM system. You can pause the video here and try to answer it on your own. So, what is a privilege escalation attack? It is a type of attack where an unauthorized user gains elevated privileges or access rights beyond what they should have. So, it allows the attacker to perform actions or access resources that are restricted to privileged users only. So now that we know what is a privilege escalation attack, let's try to see the options. Option A is role based access control. There are many access control models like RBAC, MAC, DAG, discretionary access control, rule based access control, attribute based access control. There is a different video which explains how these are implemented and where they are usually used. I will link it in the description if you are interested. RBAC is a security control that assigns permissions and privileges based on roles or job functions. RBAC does help in managing access rights efficiently, but it may not prevent privilege escalation if the initial assignment of roles is incorrect or if users can modify their own roles. So, this might not be the answer, but let's keep it aside for now. Then we have intrusion detection system. These systems are designed to detect and respond to malicious activities or attacks. While they play a vital role in identifying unauthorized activities, they are not specifically focused on preventing privilege escalation. So, this is not our answer. Let's see the next option, MAC, Mandatory Access Control. This is actually the most effective security control in preventing privilege escalation attacks. MAC is a security model that enforces access controls based on a set of predefined rules or policies. So we have subjects and objects concepts. Subjects are nothing but the users, and objects are the resources that the users need to access. In MAC, these subjects and objects are assigned labels and categories, and these labels and categories are used to determine and enforce access permissions. With MAC, access decisions are made by the system and not by individual users or administrators. It enforces that users can only access resources and perform actions that are explicitly allowed based on the established policies. So, this prevents unauthorized privilege escalation since users cannot modify their own access permissions. So, most likely, mandatory access control is the answer for this question, but let's see option D as well. Option D is SIM, that is Security Information and Event Management System, that collects, correlates, and analyzes security event logs from various sources. While SIM can provide insights into security events and help identify potential threats, it is not a control that is directly used to prevent privilege escalation attacks. So, the most effective control for preventing privilege escalation attacks is mandatory access control MAC, which ensures strict enforcement of access permissions based on predefined policies and labels and categories.
Let's go to the next question.
Which of the following is an example of MAC spoofing? Modifying the content of a file during transmission, impersonating a user or device to gain unauthorized access, impersonating and reading network traffic without permission, changing the physical address of a network interface to masquerade as a different device. Take a minute here to go through the options. You can answer here because next we'll discuss about MAC spoofing. There is an entire video which talks about spoofing, different types of spoofing, what are the countermeasures. I will link the video in the description box. I recommend going through it if you want to know about other types of spoofing. So let's talk about MAC spoofing now. MAC stands for Media Access Control, and this is a unique identifier that is assigned to network interfaces at the hardware level. This is used to identify devices on a local network. So, what is MAC spoofing? MAC spoofing refers to the practice of altering or forging the media access control, that is MAC address of a network device. In a typical network, devices communicate with each other using MAC addresses, okay? When a device wants to send data to another device on the same network, it uses the MAC address of the destination device to ensure the data reaches the intended recipient. Suppose say I have many devices on this network. If these two want to communicate and this is the source, this is the destination, if the source device wants to send data to the destination device, it uses the MAC address of the destination device to send the data. MAC spoofing is nothing but modifying the MAC address of a network interface to impersonate another device or to create a completely fake identity. This can be done for various reasons, like, for example, privacy. By changing the MAC address, a user can make their device appear as a different device on the network, which can help protect their privacy by preventing network admins or other users from tracking their activities. Another one is bypassing MAC address filtering. Some networks implement MAC address filtering as a security measure. Only devices with specific MAC addresses are allowed to connect to the network. By spoofing a permitted MAC address, an unauthorized device can gain access to the network. Another reason could be evading network identification. MAC addresses can be used to identify and track devices on a network. By changing the MAC address, an attacker can avoid being easily identified or traced by network admins or security systems. It's important to note that MAC spoofing only affects local network communications. When data needs to be sent outside of the local network, such as to the internet, the device's IP address is used for routing and not the MAC address. MAC spoofing can be performed through various methods, including software based techniques or by modifying the MAC address settings in the device's network configuration. Now, let's see some of the countermeasures against MAC spoofing. First one is port security. Network switches often support port security features that allow admins to bind specific MAC addresses to physical ports. This ensures that only authorized devices with pre-configured MAC addresses can connect to those ports, okay? Then we have MAC filtering. MAC filtering can be implemented on network devices such as routers or wireless access points to allow or deny network access based on the MAC addresses of the devices. Only authorized MAC addresses are permitted to connect while others are blocked. And then we have network access control. These systems can enforce policies that validate the identity and compliance of devices before granting network access. This can include verifying the MAC address along with other authentication methods like username, password, digital certificates, or device health checks. And then we have DHCP snooping. DHCP stands for Dynamic Host Configuration Protocol. DHCP snooping is a security feature that ensures that only legit DHCP servers on the server can assign IP addresses. This helps prevent rogue devices from assigning IP addresses and also helps detect MAC spoofing attempts. Then we have encryption. Implementing encryption protocols such as WPA2 or WPA3 for Wi-Fi networks helps protect network communications from interception and manipulation, regardless of MAC spoofing attempts. Another countermeasure is network monitoring. Regularly monitoring network traffic and analyzing MAC address usage can help identify suspicious activities and MAC spoofing attempts. Network monitoring tools can alert admins about any unauthorized MAC addresses detected on the network. Another countermeasure is security awareness and education. Educating network users and admins about the risks associated with MAC spoofing can help them understand the importance of implementing security measures and recognizing potential threats. These are some of the countermeasures. It is always recommended to implement a layered approach to network security or any security, combining multiple security measures such as encryption, authentication, monitoring to provide a more robust defense against MAC spoofing and other potential threats. Now that we know what is MAC and what is MAC spoofing, let's go back to the question. The question is to find an example of MAC spoofing. All of these options sound like, once you spoof something, you can do all of these, but we'll see what best suits a MAC spoofing attempt. Option A, modifying the content of a file during transmission. It can be done, but not directly related to MAC spoofing. Option B, impersonating a user or device to gain unauthorized access. Yes, kind of. Let's see the other two options. Intercepting and reading network traffic without permission. Yes, that can also be done using MAC spoofing. Option D, changing the physical address of a network interface to masquerade as a different device. This absolutely suits the definition of MAC spoofing. The physical address of a network interface is nothing but the MAC address. Changing the MAC address to masquerade as a different device is exactly MAC spoofing. So the answer is option D.
Let's go to the next question.
Match the following, and if you see, it talks about identification, authentication, authorization, auditing, and accounting. So to answer this question, first we'll have to know all these terms. What is identification, authentication, authorization, auditing, and accountability in cybersecurity? That is what we'll try to understand today. This is also referred to as IEEE. These are access control concepts that are related to security. Let's say that a user, suppose say user 1 wants to access a file. Okay, maybe it is you and you want to access a file. Here the user is the subject and the file is the object. So for the user to access a file, it has to go through the access control concepts. Okay, first is that it has to establish its own identity. So identification is the ability to identify a user. Like for example, my name is Navya. That is my identity. User or subject can be a system, application, people, process, anything, right? For example, when you try to access a web application on a portal, it usually asks you to log in. When you provide your username on that login page, like for example, your user ID, your email ID, account number, all those are identifications. And if it is an application or process, it can be a process ID, application ID, okay? And most of the times the identity is unique, except for like admin users, right? You just have a user ID called admin. That is not unique. And most of the times the subject's identity, right? It is public information. Like for example, your email address, your name, everything is public. Everybody knows about it. So you cannot log into an application just by having your identification. Like for example, your username. You'll also have to verify it. That verification step is called as the authentication. That is, you're verifying the identity that you claim to be. In a simple web application, how do you verify it? By providing your password. It can be passphrase, password, anything. Or, it can be your PIN. So the first step is identification and access control, and the next step is authentication. That is nothing but verifying the identification. So the username is public information usually, and the password is private. Only the subject knows what is the password, right? So there are many different types of authentication. Let's see what are those as well. Type 1 authentication is something that you know. Like for example, your password, there is a PIN number that you know or a passphrase. Then you have type 2, something that you have. It can be like an access card, it can be a token. Type 3 is biometrics, okay? That is your fingerprints, your retina scans, iris scans. And the fourth type of authentication is where you are, that is nothing but the location, like which country you're trying to log in from, or are you logging in from the office, only provide access to an application only if you are in the office network. So these are the types of authentication. Then we also have something called as single factor authentication, SFA, and multi-factor authentication. Single factor, it is the simplest form of authentication. Like for example, a user, an application, or a process, or a device will have to provide only one type of authentication, like maybe a password or a card, biometrics, or just the location. That's it. Okay. And then we have multi-factor authentication. Like the name suggests, you are using two or more factors. Like for example, you're using a password as well as a token to log in. It is considered to be the strongest form of authentication. So something to remember is that you'll have to use two types for multi-factor authentication. Type 1, type 3, or type 2, type 4, or type 4, type 1. You cannot use password as well as PIN from type 1 and say that is multi-factor authentication. It should be from different types and only then it becomes multi-factor authentication. Okay. Okay, now going back to identification and authentication, first step is identifying the subject, second step is verifying the subject, and then comes the authorization. Once a user is authentication, the access must be authorized. Like for example, if the file say it is a payslip, user 1, that is suppose say Navya, wants to access her payslip. I should be authorized only to look at my payslip and not the other payslips of the other employees, right? That is authorization. Like for example, when you board a flight, you're only supposed to take your seat. You cannot enter the cockpit because you're not a pilot. You're not authorized to be there. That is authorization. Authorization is the rights and permissions that are assigned to the subject. That is, it is determining the level of access to a resource by that subject, sorry. So authorization happens after authentication, and then it decides what identity can do and cannot do. Authorization is generally provided by using access control models like, MAC, that is mandatory access control, RBAC, role based access control, rule based access control, DAC, discretionary access control. There are many access control models that are used to provide authorization. Okay, now we have the identity, and then we have verified the identity, that is authentication, and then we have also decided what the identity can do and cannot do, that is authorization. Next is auditing. Auditing is monitoring. What is it monitoring? It is monitoring the actions that are taken by the identity or the events that are related to that login, right? Auditing is the programmatic means of, tracking all the actions that were taken by the subject. It is nothing but recording the events, okay? The purpose of doing auditing is to establish accountability, and all these details are recorded in a log file. Okay, auditing is not just recording the subject and objects events, but it also collects logs related to the system. Like for example, operating systems and many of the applications and services, they have native feature of logs. So why is auditing required? It helps us to detect any malicious activity activities, any unauthorized activities. It helps us to validate the compliance, the security policies of the organization. It also holds the subject accountable for their actions or activities. Okay. So the next concept is accountability. According to NIST, the accountability is defined as the principle that an individual is entrusted to safeguard and control equipment, keying material and information, and is answerable to proper authority for the loss or misuse of that information. So, to put it in simple words, right, accountability is the ability to hold an individual, that is a subject, user, process, application, accountable for their actions on a sub object. On an object can be a database, file, application, system, anything. And why do we require accountability? Because it ensures that every information asset is owned. It is talking about the ownership. It can be an information asset or an action on the information asset is owned by an individual, that is a subject, a user in the organization, and it makes that person responsible for that action or for that information asset. And why is this ownership required? It is required to enforce any organization security policy. So you can have effective accountability only if you can prove a subject's identity and also track their activities. So accountability is reviewing the log files that were collected in the audit term, right? So in auditing, you're collecting the log file. In the accountability, you're reviewing the log file to check for any compliance violations or all the subjects are doing what they're supposed to do and nothing apart from that. So basically, to identify any malicious or unauthorized activity. Accountability is initiated at the identification step. Something to remember is also that we achieve non-repudiation by all these steps. That is, non-repudiation is made possible by identification, authentication, authorization, auditing, and accountability. What is non-repudiation? Non-repudiation is nothing but the subject or user who did the activity cannot deny that they did the activity because you have evidence. Now that we know IEEE concepts, let's go back to the question to answer it. Identification is nothing but providing the subject's identity. How do you provide that? By using the username. Okay, identification is username, user ID, or email address. It can be anything, right? And then you have authentication. Authentication is verifying that identity, like you're providing your passwords, pin, token, access card, all that is authentication. In this, which one will match? User group, no. Owner of an event, no. Passphrase, yes, it is just like your password. So authentication is with passphrase. Then we have authorization. Authorization is trying to tell the identity what they can do and what they cannot, and it is mostly related to user groups. In the IT world, you put the users in groups. So admin has their own admin group. Admin can do all the activities. User who can only read is put into, say, read group, where they can only read everything that is happening, cannot edit anything. So authorization matches with user groups. Then we have auditing. Auditing, like we said, is related to log files. And then accountability is where you establish the ownership of an event. So this is the right answer. Identification is username, authentication passphrase, authorization user group, auditing log files, accountability owner of an event.
Let's go to the next question.
What term indicates the average time between hardware collapses? Option A, mean time to repair. Option B, mean allowable downtime. Option C, mean time between recovery. Option D, mean time between failures. Option A is mean time to repair, that is MTTR. MTTR is nothing but the average amount of time it takes to repair a damaged system or device, that is down. So it talks about the mean time it takes to repair. It is not talking about collapses. Collapses is nothing but failures, hardware failures. Okay. Then we have mean allowable downtime. This is a made up term, there is something called as maximum allowable downtime, MAD, that talks about how long it would take for an interruption in service to kill an organization. But this is not that. That is maximum allowable downtime, and we are talking about a made up term here, that is mean allowable downtime. Okay. And then option C is mean time between recovery. This is also a made up term, so this is not our answer. Option D is mean time between failures. That is nothing but MTBF. MTBF actually talks about the average time between hardware collapses or failures. That is, it talks about how long a new or repaired system or component will function on average before it fails. So the answer to today's question is option D, mean time between failures, which talks about the average time between hardware collapses.
Let's go to the next question.
What is an example of true positive? Option A, firewall allows unpermitted traffic. Option B, firewall allows permitted traffic. Option C, firewall blocks unpermitted traffic. Option D, firewall blocks permitted traffic. Option A, where a firewall allows unpermitted traffic, this is an example of false negative. Firewall allows permitted traffic is an example of true negative. Firewall allows unpermitted traffic is an example of true positive. Firewall blocks permitted traffic is an example of false positive. So the answer to our question today is option C, firewall blocks unpermitted traffic. This is a true positive.
Let's go to the next question.
When should we not consider updating business continuity plan and disaster recovery plan? So the question says, when should we not update the DR or BCP plan? Okay. Option A is when it is a year since the last review or update. Option B, when the senior management changes. Option C, when a disaster is declared. Option D, when there's a major component change. Option E, when the company splits into several companies. So option A is when it is a year since the last review or update. Remember that DR plan or business continuity plan should be updated at least annually or when there is any significant change. So this is not our answer because you have to update it annually. Option B, when the senior management changes. Yes, this is considered as one of the major changes in an organization and we should update our DR plan. So this is also not our option. Option C, when a disaster is declared. Yes, this can be our answer. So the whole idea of having a plan updated is not to have, to update it or review it when there is a disaster or when there is a disaster declared. So this is not the right time to update or review the DR plan, okay? But we'll see the other options as well. Option D, when there's a major component change. Yes, this is considered as a significant change. So we will have to update our DR and BCP plan. Option E is when the company splits into several companies. Yes, that is also considered as a major change whenever, the company splits into several different companies or when there is an acquisition or merger, you have to update your DR and BCP plan. So the answer is to this question, when it is not considered to update your BCP or disaster plan is when a disaster is declared.
Let's go to the next question.
Match the following DNS terms with their right definition. So we need to know about shadowing, footprinting, zone signing, and spoofing. What does DNS stand for? Domain Name Resolution. This is a hierarchical and decentralized naming system which resolves a fully qualified domain name, that is FQDN, to an IP address. That is, it allows the use of user-friendly names instead of using the IP addresses. Okay. It operates over UDP port 53. On a higher level, when you type in any domain in your browser, like for example, google.com, a request is sent to the DNS server asking what is the IP address of this domain. That is, this domain is google.com in this case. And then the DNS server will give you the IP address saying this is the IP address of google.com. Once you have the IP address of the domain, you go to that IP address, maybe it is a web server, and then you request for maybe say a file, and then you get a response from the web server saying this is the file here. Yeah. Let's see some of the threats to the DNS infrastructure. The first one is footprinting. Here, what an attacker does is he attempts to gather DNS zone data information for a domain, okay? Like using zone transfer. We'll see what is transfer in a minute. This is in order to get the entire target environment mapped out. Like, for example, he's trying to gather DNS domain names, computer names, IP addresses, right? Zone transfer is a process by which the information between different DNS servers are maintained to be the same. Like they send copies of information from one DNS server to the other so that all of them have the same information. Okay. Then there is denial of service attack. Here, like any other DOS attack, the availability of network services is impacted by flooding one or more DNS servers in the network with queries. Then we have the redirection attack. Here, an attacker can redirect queries for DNS names to servers that are under the control of the attacker. Then we have spoofing. Here, when a DNS server accepts and uses incorrect information, right, from a host that is not supposed to give this information, then it is called spoofing. DNS spoofing is in fact nothing but malicious cache poisoning attack where forged data is placed in the cache of the name servers. Then we have data modification as well, like for example, an attempt by the attacker to spoof valid IP addresses in the IP packets that the attacker has created. When somebody does this, it gives the packets the appearance of coming from a valid IP address. And with a valid IP address, the attacker can gain access to the network, destroy data, or conduct other attacks. And then we have DNS shadowing attack. Here, the attacker can gain access to the domain registrant's account and then create subdomains from the parent domain. This is to draw visitors to these malicious or, bogus sites, that is the subdomains. When DNS was created, it was created only from the functionality perspective. There was no security in mind. Later came the security with DNSSEC, that is DNS security extensions. This provides origin authority, data integrity, and authenticated denial of existence, but it does not provide confidentiality. So in DNSSEC, right, it uses a process called zone signing, in which it uses digital certificates to sign the DNS records. This is nothing but validating zone transfers with a digital signature. Now that we know what is DNS, a little bit about DNSSEC and the threats to the DNS infrastructure, let's go back to our question and try to answer it. The first one is shadowing. Shadowing is nothing but creating bogus subdomains. Next, we have footprinting. Footprinting is gathering DNS domain names, IP addresses, computer names, right? Zone signing is validating zone transfers, and this is done with a digital signature. Then we have spoofing. Spoofing is nothing but cache poisoning. Okay. So this is the answer. Shadowing create bogus subdomains. Footprinting gather DNS domain names and IP addresses. Zone signing validate zone transfers. Spoofing cache poisoning.
Let's go to the next question.
Which of the following is true? Option A, SOAP API supports XML, JSON, YAML. Option B, SOAP API is tolerant of errors. Option C, SOAP is used in stateless operations. Option D, SOAP works well in distributed environments. To understand this question, let's see what is an API and what are the types, what is SOAP, okay? API stands for Application Programming Interfaces. API is a mechanism that enables two software components to communicate with each other, and this communication is done using a set of definitions and protocols. API allows the developers to interact with web services. APIs are usually secured using API keys. These API keys should be carefully protected to avoid unauthorized access to the APIs. Okay. In cloud, APIs can differ greatly between different cloud service providers, and depending on how the applications are built or implemented, maybe it can make it difficult to seamlessly move from one environment to another one. There are two types of APIs that are commonly used, REST and SOAP. REST stands for Representational State Transfer, And SOAP stands for Simple Object Access Protocol. SOAP is defined as a protocol specification that is used for exchanging structured information in the implementation of web services. REST is defined as a software architecture style consisting of guidelines and best practices for creating scalable web services. So, REST is scalable and scaling is really complex in SOAP. SOAP is a standards based web services access protocol. It has been in the use since, early 2000s, and REST is relatively new compared to SOAP. REST solves some of the complexity problems associated with SOAP, and it also provides a simpler method of accessing web services. In SOAP, messaging services are implemented using XML, and this was actually developed to replace older technologies. Okay, it's older technologies like DCOM and CORBA. DCOM stands for Distributed Component Object Model, and CORBA stands for Common Object Request Broker Architecture. And these older technologies lacked good internet compatibility. And these older technologies relied on binary messaging, the XML messaging that SOAP uses, right? That works better over the internet. SOAP is highly extensible, so it is used to provide WS dash features, okay, like for example WS addressing, WS policy, WS security, WS federation, etc. SOAP is relatively difficult to use, and also it has the tendency to fail ungracefully. SOAP also needs additional bandwidth compared to REST. REST supports formats like, JSON, XML, YAML, but SOAP only supports XML. REST uses HTTP or HTTPS for data transfer. SOAP uses HTTP, HTTPS, FTP, and SMTP. When it comes to performance, REST provides good performance. SOAP is slower and rigid. REST is widely used. SOAP is usually used when REST is not possible. Let's see some of the example situations where REST and SOAP are used. REST is used when bandwidth is limited, when stateless operations are used, when caching is required, and it works in direct point to point communication scenarios. SOAP is used in asynchronous processing, format contracts, stateful operations, and it works well in distributed environments. REST uses simple URIs and URLs. This makes it faster as well, and there is no extensive processing required in REST. REST is efficient because it uses smaller message formats, whereas SOAP uses XML for all messages. SOAP has built in error handling. SOAP is highly intolerant of errors. SOAP encapsulates data in a SOAP envelope and then uses HTTP or other protocols to transmit the encapsulated data. We have to make sure API access is secured. This is done by using SSL in REST and message level cryptology in SOAP. Now that we understand what is an API and also the difference between REST and SOAP, what are their characteristics, let's try to answer the question. Which of the following is true? SOAP API supports XML, JSON, YAML. This is wrong because SOAP only supports XML. Option B, SOAP API is tolerant of errors. This is also wrong because SOAP is highly intolerant of errors. Option C, SOAP is used in stateless operations. This is also wrong because SOAP is used in stateful operations and REST is used in stateless. Option D, SOAP works well in distributed environments. This is correct because SOAP does. So the answer to today's question is option D, SOAP works well in distributed environments.
Let's go to the next question.
How is the following intellectual property protected with? So we need to map what intellectual property, that is customer list, brand name, newly invented machine, music, is protected using what? Okay. Let's see what is an intellectual property. The short form for this is IP. Okay. Any work or invention that is the result of creativity is the intellectual property or IP. Strong contract language should be used to ensure the protection of intellectual property when it is created in the cloud. Okay, there are 4 intellectual protection types. Let's see them one by one. The first one is copyright protection. This protects the expressions of ideas or creative work. This protects the expression of ideas rather than the ideas themselves. Okay, remember that. Copyright provides author or owner rights. The work does not have to be registered or published to be protected by copyright. The author controls how the work is distributed, reproduced, or used. The limitations to copyright include the fair sale and the fair use policies. For example, movies, music, paintings, books, computer programs, technical drawings are protected by copyright. Copyright provides protection for the lifetime of the author plus up to 70 years after the death of the author. The next protection type is trademarks. This protects any goods that identify and distinguish one manufacturer or seller from the others. For example, it can be any word, symbol, name, graphic, label, device, or a combination of these, like company brands, operating system logos, etc. This is protected from anyone trying to steal the organization's look and feel. Then the third protection type is patents. This protects inventions, processes, materials, decorations, plant life, etc. This grants a property right to the inventor. The inventor should file for the legal ownership of an invention to get a patent. The owner has exclusive rights of the invention for 20 years. The invention must be novel and non obvious. Then the fourth protection type is trade secrets. This requires maintaining secrecy. It never expires. This can be like protected forever, okay? Like, for example, it protects processes, formulas, commercial methods, customer list, or client list. There are few trade secret requirements. Like, for example, it must be genuine and non obvious. It must provide the owner a competitive or economic advantage and therefore have value to the owner. It must be reasonably protected from disclosure. Okay. Now that we know what is intellectual property and the types, how it is protected, let's go back to the question and try to answer it. So, the customer list should be protected by trade secret. The organization should maintain secrecy. The brand name, logo, everything is protected by trademark. Newly invented machine is protected by patent. Music, drawings, movies, everything is protected by copyright. So this is the answer. Music, copyright, newly invented machine, patent, brand name, trademark, customer list, trade secret.
Let's go to the next question.
Which of the following is not verified by Stride? Option A person successfully identifies as another by falsifying data. Option B URL parameters are changed without authorization. Option C spinning up resources that might impact the organization's budget. Option D a non-admin user gains access to make admin level changes. To understand this question, let's first try to understand what is Stride. Stride is a threat modeling methodology. The goal of threat modeling is to identify or determine any weaknesses in the application and the potential ingress and egress and actors involved. This is done before the weakness is introduced to production. Stride characterizes known threats according to the kinds of exploits that are used. It provides mnemonic for security threats in the 6 categories. The first one, that is S, stands for spoofing. Here it asks the question, can the attacker assume the identity of a subject? T stands for tampering. Can an attacker alter data? R stands for repudiation. This asks the question, can the user deny their action? I stands for information disclosure. Can the attacker obtain the information without authorization? D stands for denial of service or DOS attack. Can the attacker overload the system to deny legitimate access? E stands for elevation of privilege. Can the attacker gain a privilege level above what is permitted? Each of this threat is a violation of a desirable property for a system. Like spoofing is a violation of authenticity, tampering is a violation of integrity, repudiation is a violation of non-repudiation, information disclosure is a violation of confidentiality, denial of service or DOS is a violation of availability, elevation of privilege is a violation of authorization. Now that we know what is tried, let's try to answer the question. Option A is a person successfully identifies as an other by falsifying data. This is nothing but spoofing. Spoofing is verified by Stride, so this is not our option. Option B is URL parameters are changed without authorization. This is nothing but altering data. That is the second one, tampering. So tampering is also identified by Stride, so this is not our option. Option C, spinning up resources that might impact the organization's budget. Stride never verifies anything related to the budget specifically. So this might be our correct answer, but let's see option D as well. Option D is a non-admin user gains access to make admin level changes. This is nothing but elevation of privilege, and hence it is also verified by Stride. So the only option that is left is option C, which is not verified by Stride, and that is our option.
Let's go to the next question.
What represents a good risk management? Option A, quantify risk. Option B, eliminate the inherent risk. Option C, minimize the residual risk. Option D, apply the best security controls. The first option is quantify risk. There are three options in risk assessment to carry out the process, right? First is quantitative risk assessment, qualitative, and hybrid. Quantitative risk assessment is assigning actual monetary value. Qualitative is assessment based on the experience, and hybrid is combining quantitative and qualitative. So, quantifying risk is, yes, one of the methods to carry out risk management, but that is not the ultimate goal or, describes a good risk management. So, this is not the option. Option B says eliminate the inherent risk. Option B is eliminate the inherent risk. Inherent risk can be described as the untreated risk. That means there is no control in place, no security safeguards, right? Before that, whatever risk is present, the natural level of risk, that is called as inherent risk. Inherent risk can also be referred to as the current risk level of the organization, taking the existing set of controls in account, and the existing set of controls are considered to be incomplete or not the ideal choice. Always remember that the inherent risk can never be completely eliminated. So option B is not our option here. Option C says minimize the residual risk. Residual risk is the risk after countermeasures or safeguards are applied. So yes, for now, option C looks like a very good choice, because risk management is nothing but the process of identifying, analyzing, and then reducing the risk to an acceptable level. So let's consider this option for now, but we'll also see option D, which says apply the best security controls. Okay, we are applying the best security controls to minimize the residual risk or the actual total risk or the inherent risk, right? Though this is a very good practice to apply the best security controls, you'll also have to make sure it is appropriate to your organization. But the ultimate goal, how we can measure a risk management process, if it is successful or no, is by option C, to check if it minimizes the residual risk. So the correct answer for today's question is option C, minimize the residual risk.
Let's go to the next question.
Which one of the following is EAL4 in common criteria? Option A, semi-formally verified, designed and tested. Option B, methodically tested and checked. Option C, semi-formally designed and tested. Option D, methodically designed, tested and verified. What is common criteria, right? CC. It is one of the ways to evaluate cloud service providers' services or products. It is an international set of guidelines and specifications that was developed for evaluating information security products. This is to ensure that they meet an agreed upon security standard for government entities and agencies. Okay. This is also referred to as ISO 15408. This is evaluating these information security products to ensure that they do what they say they do. Okay. Common criteria needs to be verified by a vendor neutral third party. It tells us how thoroughly the product has been tested. Common criteria focuses only on certifying the product. It does not include business or administrative processes. Now let's see the key concepts of common criteria. The first one is TOE, that is target of evaluation. This is the vendor, product, device, or system that needs to be reviewed for CC certification. Next one is PP, that is protection profile. This mainly answers the question, what does the customer need? That is the desired security features. Like it identifies security requirements for a class of products, like for example, a firewall or intrusion detection systems. Products can comply with more than one protection profile. Okay. Then we have something called as ST. It stands for security target. This is the claim of security from the vendor that are built into the product. The product is the target of evaluation. This is the vendor self-assessment detailing how the product conforms to the relevant protection profile. Then we have EAL, that is evaluation assurance levels. This talks about how thoroughly the product was tested. Evaluation assurance levels have ratings from 1 to 7, that is EAL1 to EAL7. EAL1 provides the lowest level of evaluation and EAL7 provides the highest. The higher the level of evaluation, that means the more quality assurance tests it has undergone. This doesn't necessarily mean that it is more secure. Okay, this is talking only about the testing, quality testing that happens. Now let's see the levels. Level 1 is functionally tested. Level 2 means that the product is structurally tested. Level 3 is methodically tested and checked. Level 4 refers to the product being methodically designed, tested, and reviewed. EAL 5 is semi-formally designed and tested. Sixth one is semi-formally verified, designed, and tested. The last level, that is the seventh one, which provides the highest evaluation, is formally verified, designed, and tested. So if you have worked in a testing team or got your software, tested, you might have noticed that usually functional testing is the first thing that happens. That is, they're testing for the functions of that product or services. Suppose, say, if the product needs to take an input A and provide an output B. So that is what they'll test for. They'll input A and then check if the output is B. Then after functional testing, it is usually the structural testing, first and second. Now we'll go back to the last one, that is the highest one. Obviously, formally designed, verified, and tested should be the last one because of the name formally everything is done, right? Before that, we have two levels of semi-formally done, tested. First one is semi-formally designed and tested. That is the fifth option, fifth level. The sixth level that you've seen, it is verified, designed, and tested. Verified adds a higher level of evaluation. Hence, sixth one is verified and fifth one is only designed and tested. And then third and fourth, we have methodically tested. Third one is only tested and checked, whereas the fourth one provides higher evaluation than the third one, being designed, tested, and reviewed. So you don't have to memorize this. Try to understand the logic and you'll be able to form these levels. So level 1 is functionally tested, level 2 is structurally tested, level 3 is methodically tested and checked, level 4 is methodically designed, tested, and reviewed, level 5 is semi-formally designed and tested, level 6 is semi-formally verified, designed, and tested, level 7 is formally verified, designed, and tested. Now let's see the steps to successfully submit a product for evaluation according to the common criteria. The first step is that the vendor must detail the security features of a product using a security target, that is ST. The second step is that the product, along with this security target, right, goes to a certified laboratory for testing the product's security features. and to evaluate how well it meets the specifications defined in the protection profile. Then step 3, a successful evaluation will lead to an official certification of that product. Okay. Now that we understand what is common criteria, let's go back to our question. So in this question, we are looking for the level 4 of common criteria. Option A is semi-formally verified, designed and tested. This is level 6. Then next we have methodically tested and checked. This is level 3. Then we have semi-formally designed and tested. That is level 5. And option D is methodically designed, tested and reviewed. That is level 4. So the right answer to our question today is option D, methodically designed, tested and reviewed. That is level 4 of common criteria.
Let's go to the next question.
Which of the following best enforces separation of duties by dividing permissions and responsibilities among multiple users? Option A, role-based access control, RBAC. Option B, discretionary access control, DAC. Option C, mandatory access control, MAC. Option D, attribute-based access control. There's another video of mine which explains what is an access control, what are the different types and how they are used and where it is required. I will link the video in the description. I recommend going through it if you don't know what is an access control or what are the types, okay? Now let's see the options. First one is role-based access control. RBAC is an access control that assigns permissions and responsibility based on the user's roles within an organization. It enforces the principle of least privilege by dividing access permissions into roles and ensuring that users are assigned only the privileges necessary for their specific roles. This separation of duties is a crucial aspect of RBAC as it helps prevent conflicts of interest and potential abuse of privileges. So, by the explanation of RBAC, this looks like the answer to our question, but let's go back and see the other options as well. Option D is DAC. DAC is an access control model where the owner of a resource, like the file owner, has the discretion to decide or determine who can access and modify that resource. It does not explicitly enforce separation of duties, so this is not the answer. Mandatory access control, that is MAC, is an access control model that assigns access permissions based on predefined rules and labels. It is typically used in highly secure environments and does not directly address the separation of duties, okay? So this is also not the answer. Option D is attribute-based access control, ABAC. This is an access control model that makes decision based on a combination of attributes associated with the user, resource, and environmental conditions. ABAC provides a flexible and fine-grained access control mechanism, but it does not specifically focus on the separation of duties. Okay, so RBAC, which says, okay, if somebody is an admin, they have a specific set of duties, or if they are an operator, they have a specific set of duties. So that enforces separation of duties. So option A, role-based access control, is the answer.
Let's go to the next question.
Where is the transparent encryption most used? Option A, infrastructure as a service. Option B, platform as a service. Option C, software as a service. Option D, all of the above. Let's see the different encryption types associated with different service models in cloud. The first one is infrastructure as a service model encryption. In this, we have basic storage level encryption, which provides protection only against hardware theft or loss, that is media theft or loss. The encryption engine here is located on the storage management level, and the keys are usually held by the cloud service provider. This type of encryption is relevant to both object and volume storage. Next, in infrastructure as a service model, we have volume storage encryption. This provides protection against media theft or loss, that is hardware theft or loss. It provides protection against external admins like cloud service providers accessing the data, and also provides protection against snapshots and storage level backup being removed or taken from the system. But volume storage provides no protection against access made through the instance or application running on the instance. There are two methods to implement volume storage encryption. First is the instance-based encryption, where the encryption engine is located on the instance. Next is proxy instance encryption, proxy-based encryption. The encryption engine here is located on a proxy instance or appliance. Proxy instance is a secure machine that handles all cryptographic actions, including key management and storage. Okay. Next, in infrastructure as a service encryption, we have object storage encryption. This is mostly server-side storage level encryption, and this is not so effective. But external mechanisms can be used in storage level encryption. For example, the first one is file level encryption, like digital rights management solutions, that is DRM solutions. Usually this is implemented at the client side, and this preserves the original file format. Then in the external mechanism, we have client or application level encryption. In this, the encryption engine resides in the application that is utilizing the object storage, and this can be integrated into the application component or by a proxy. Next, we have PAS encryption. PAS, we have two types, database encryption and proxy encryption. First, let's see database encryption. In database encryption as well, we have different types. The first one is file level encryption. In this, it encrypts the volume or folder of the database. Suppose say you have a database. This database resides on a database server, and the database servers usually reside on volume storage, and this volume or folder of the database is encrypted. The encryption engine and keys here reside on the instance attached to the volume storage. This provides no protection against attacks with access to the app or the instance OS or the DB. Next, we have application encryption and database encryption of PAS encryption. The encryption engine here resides in the application that is utilizing the database. This can be a robust mechanism, but the performance is very much impacted here because the data is encrypted before it reaches the database, right? It is very challenging to perform searches, indexing, and metadata collection. Hence, the performance impact is more in application encryption. And then we have transparent encryption in database encryption method. This is specific to the databases. The encryption engine in transparent encryption resides with the database and is transparent to the application. It is integrated with the actual database processes and works as part of the ongoing workflow. Okay? In transparent encryption, we can, encrypt specific tables or even only rows or columns of the tables within the database against, encrypting the entire database itself. This provides protection against hardware theft or loss, backup system intrusions, and some DB and app level attacks. In PAS, we also have proxy level encryption. This is exactly how we discussed earlier, right? That is how it happens. We have a proxy machine. And then we have SaaS, software as a service encryption. In SaaS, we have either provider managed encryption or proxy encryption. So now that we know what are the encryption types and different service models of cloud, let's go back to our question. So the question says, where is the transparent encryption most used? Like we discussed before, transparent encryption is specific to DBs, and DB encryption is used in PaaS, that is platform as a service. So the answer for today's question is option B, platform as a service model. That is where we usually use transparent encryption.
Let's go to the next question.
Which of the following is a false statement? Option A, symmetric encryption is cheap, asymmetric encryption is expensive. Option B, symmetric encryption is slow, asymmetric encryption is fast. Option C, symmetric encryption doesn't scale well, asymmetric encryption scales well. Option D, symmetric encryption is computationally inexpensive, asymmetric encryption is computationally expensive. There are two major encryption types. Symmetric encryption,
and asymmetric encryption. Symmetric encryption is also called as shared key or shared secret encryption. Asymmetric encryption is called public key encryption. In symmetric cryptography, we use only one key. The same key is used to decrypt and encrypt. Suppose you have the plain text, you are using key 1 to encrypt it and convert it into ciphertext. Plain text is something that everybody can make sense of, like it's written in normal language. Ciphertext is something which is gibberish and it doesn't make sense to the hackers if they don't have the key, to anybody for that matter, right? Now, if I want to decrypt the ciphertext to get the plain text, I'm going to use the same key, that is key 1. Because you're using the same key to encrypt and decrypt, this key needs to be a secret. Hence, symmetric encryption is called as shared key or shared secret key. Now, let's see how asymmetric encryption works. You have the plain text. You use public key to encrypt it and convert it to ciphertext. Then if you want to decrypt it, you use private key. So asymmetric encryption uses a mathematically related public-private key pair. If you're using public key to encrypt, then you're using private key to decrypt it. If you're using private key to encrypt, then you're using public key to decrypt it. Because symmetric encryption has only one key and one mathematical process, it is faster comparatively and computationally inexpensive compared to the asymmetric encryption. So asymmetric encryption is slower and computationally expensive and compared to the symmetric one. Also, cost-wise, symmetric is less expensive than the asymmetric encryption. Symmetric encryption only provides confidentiality, whereas asymmetric encryption provides confidentiality, authenticity, that is the message origin, non-repudiation, and it can also be used with hashing to provide integrity. Symmetric key, the key distribution method requires an out-of-band method because there is only one key and that key needs to be kept as a secret. But in asymmetric encryption, you don't need out-of-band key distribution because it is fine to share the public key with anyone. Only the private key needs to be a secret. So the private key is always with the owner. It is very rarely, almost not shared with anybody. Only the public key is shared. Symmetric encryption is generally used for handling large amount of data, whereas asymmetric is for small amount of data. Symmetric encryption doesn't scale well, whereas asymmetric encryption relatively scales well as users increase. The use cases for symmetric encryption are data at rest encryption, TLS session keys. Use cases for asymmetric is digital signatures, exchange of shared secret keys. So I mentioned that symmetric encryption requires out-of-band key distribution. Asymmetric encryption can be used to exchange shared secret key, that is the asymmetric key. Once the symmetric keys are exchanged using out-of-band key distribution method, that is we are using asymmetric encryption here, we can start using asymmetric encryption from there onwards. Examples of symmetric encryption algorithms: triple DES, AES, IDEA, Blowfish. DES is also symmetric, but DES is considered to be not secure. Asymmetric algorithms include RSA, ELGAMAL, elliptical curve, ECC. So now that we know the differences between asymmetric and symmetric encryption, let's go back to our question. Which of the following is a false statement? Symmetric encryption is cheap, asymmetric encryption is expensive. Yes, that is correct. Symmetric encryption is slow, asymmetric encryption is fast. No, when compared with each other, asymmetric is slower than symmetric encryption because symmetric encryption has only one key and one mathematical process. Symmetric encryption doesn't scale well, asymmetric encryption scales well. That is also correct. Symmetric encryption is computationally inexpensive, asymmetric encryption is computationally expensive. That is also correct. So the right answer to our question is symmetric encryption is slow and asymmetric encryption is fast. That is option B, which is a false statement.
Let's go to the next question.
What are the two types of TLS protocols? Option A, establish and record. Option B, handshake and record. Option C, establish and handshake. Option D, negotiate and establish. TLS stands for Transport Layer Security. It's a security protocol which is very widely used. It is a successor of SSL protocol. It encrypts data sent over the internet just to make sure that eavesdroppers or hackers are unable to see what is transmitted. It is usually used to secure web traffic, but it can be used for other network communications as well. TLS uses public key cryptography to exchange a shared secret key. Also, TLS uses a new symmetric key for each secure connection or session. This key is hence called a session key because it is generated for every session. TLS has two protocols. The first one is TLS handshake protocol and the TLS record protocol. The handshake protocol is responsible for negotiating and establishing the TLS connection between the two parties that want to communicate. The handshake protocol enables a secure communication channel. It exchanges the information needed for authentication between the two parties, right? It is responsible for negotiating what encryption algorithms will be used for the actual communication. It is also responsible for the encryption key exchange between the two parties. Now, coming to the record protocol is the one that is responsible for the actual secure communication. It verifies the data integrity and the origin. Okay. So, to summarize, TLS has two protocols, handshake and record. Record protocol is responsible for the actual secure communication that the data is transferred, right, from one party to the other. But the handshake protocol is responsible for setting up that secure communication. It is authenticating, it is exchanging the keys, it is negotiating the encryption algorithms. So the first initial setup is done by the handshake protocol, and then the actual secure communication, it is the responsibility of the record protocol. So to go back to our question, option B, handshake and record, is the correct option because those are the two protocols used by TLS.
Let's go to the next question.
What is the first step after installing a software? Option A, apply baselines and patches. Option B, provide access to the right users. Option C, change the default credentials. Option D, vulnerability scanning. So if you look at all the options, all of them look like good security measures that can be taken. Option A is to apply baselines and patches. Yes, we have to apply the baselines and patches. Let's see the option D, provide access to the right users. Yes, we have to provide access to the right users and, not provide access to the ones that are not required. Option C is to change the default credentials. If I compare the first three, changing the default credentials look more immediate step that needs to be taken. Let's see option D as well. It is vulnerability scanning. You have to scan the software, but it is lower on the list when compared to changing the default credentials because these default credentials are very well known. Like most of us know what are these default credentials. Usually it is admin, and all of the software or application packages come with a default set of credentials that can be used to, log into admin portals, admin interfaces. And these credentials are mentioned in manuals, like you get manuals with the application, right? It's mostly mentioned there. These default credentials are present so that they allow the first time access to the software, but they need to be changed as soon as we install them to a stronger password. And also there are many automated scanning tools that can be used to probe for, such interfaces where default credentials are used. So the first step that you need to do always after installing the software is to change the default credentials. So the answer to our question is option C, change the default credentials.
Let's go to the next question.
What is not achieved by digital signatures? Option A, integrity. Option B, confidentiality. Option C, non-repudiation. Option D, authenticity. To answer this question, let's see what is a digital signature and how it can be achieved. Digital signature, these are almost like handwritten signatures or a stamped seal. The only thing is they are used for a electronic message, software, or a digital document. Digital signatures use asymmetric cryptography. Some of the signing algorithms that are used are RSA, DSA, that is digital signature algorithm, and ECDSA, that is elliptic curve digital signature algorithm. Now let's see how to create a digital signature. Suppose say I want to send a message. First, let's talk about the sender's side. So I send this message through a hash function to generate a message digest. That is a hash value. In this case, let's assume that it is 1234. Now that we have this hash value, I will send this hash value through an encryption function. And I will use my private key, that is sender's private key, to create the encryption, to encrypt this. Once I encrypt, that becomes the digital signature. Now I take the message as well as the digital signature and send it to the receiver. Now what will the receiver do? First, he will take the message, send it to the hash function and create a hash. That hash value should be equal to what was created before, that is 1234. And now he will take the digital signature, send it through the decryption function, and to decrypt, he will use my public key, that is sender's public key. Once it is decrypted, it should create the same hash value. If both the hash values are equal, then the message is not tampered with. That means that the document or the message was not modified intentionally or unintentionally from the time it was digitally signed. That means we have integrity here. If the message was tampered or modified, then the hash value would have changed, but in this case it has not. So there is integrity. Okay. And because the receiver was able to decrypt the message using the sender's public key, that means the message is authentic. The message that was encrypted by the sender's private key can be decrypted only using the sender's public key, and the private key only the sender has it. So now we know that the message was sent by this sender alone. So it proves the origin of the message. Now coming to the non-repudiation part. Non-repudiation is a combination of integrity and the origin of the message, that is authenticity. So here the sender cannot deny that he sent the message and that exact message was sent. That exact message was sent because of the integrity. He sent the message because of the authenticity. Integrity we achieved by checking the hash value, and authenticity we achieved by decrypting the message using the sender's public key. So with digital signature, we can achieve integrity, authenticity, and non-repudiation. But we don't achieve confidentiality because the message that we send, the actual message, was unencrypted. So to go back to our question, option A, what was not achieved by digital signature? Integrity. Integrity was achieved because of the hash values. Next one is confidentiality. Confidentiality is not achieved because the actual message that we sent was unencrypted. Next is non-repudiation. This was also achieved because we have the integrity and authenticity, that is message origin, and the sender cannot deny that the message was sent by him and the same exact message, right? Then we have authenticity as well because we were able to decrypt the message digest using the sender's public key, which was encrypted using the sender's private key, and only the sender has the private key. So the answer to today's question is confidentiality.
Let's go to the next question.
What would be the best solution to help adhere to the data requirements that are mandated by geographic borders? Option A, firewall. Option B, IDS. Option C, IPS. Option D, geofencing. Here the question is asking what can we do to provide security based on these geographic borders? That is nothing but location. Now let's try to understand what is a firewall, IDS, IPS, or geofencing, and then see how we can answer this question. What are firewalls? These are the primary network security controls that are used to separate networks of differing security levels. So different security levels will have the firewall setup. That was the traditional way how we used to do it. And then we provide access only to the authorized connections. Usually in traditional systems, there are three zones where firewalls are used: the trusted intranet, untrusted internet, and the DMZ, that is the demilitarized zone, that has all the publicly accessible servers. In cloud, firewalls are implemented using the network security groups by the customers. Now let's see the types of firewalls. The first one is the stateless firewall, where it uses the source and destination IP addresses to make the decisions, also the port and the service numbers. Next, we have dynamic firewall. Here, the filters are based on signatures, behavior, heuristics, anomalies, and artificial intelligence. Next, we have is next generation firewall. This has the characteristics of IDS and IPS as well, and it manages traffic through micro-segmentation policies. Host-based or software firewall. Most of the operating systems come with a configurable firewall, and in cloud, these are used to protect the host directly and the virtual machines running on the hosts indirectly. Then we have hardware based firewalls. For example, hardware based firewalls are used by the cloud service providers to protect the cloud infrastructure, that is, including all the customer applications and data, right, from the internet or an untrusted network. Then we have web application firewall, that is WAF. It is a layer 7 firewall. WAF provides application layer security for web applications. It filters out potentially malicious HTTP requests. WAF is effective against DDoS attacks. Next, we have database active monitoring, DAM. This is again an OSI layer 7 monitoring device. It understands SQL commands. It filters information and commands that are intended for a database. This can be agent based or network based. It tracks, monitors, and analyzes access to sensitive databases by privileged and as well as normal users. Okay, this can help to prevent SQL based attacks. Next, we have XML gateway or XML based firewall. These are most commonly deployed in line between the firewall and the application server to validate the XML code before it reaches the application. Okay. It defends against message and parser level attacks. It can also defend against familiar web-based attacks like, for example, highly nested elements, recursive or coercive parsing, schema, and WSDL poisoning. WSDL is Web Service Definitional Language. It also filters requests through REST APIs for potential security issues. It can either be hardware or software. It can implement controls such as DLP, AV, etc. Next, we have API Gateway. This moderates calls, authorization, and access controls to APIs and enforces security requirements. This can also be implemented as a proxy. Next, let's see what are intrusion detection systems and intrusion prevention systems. This can impact performance. IDS is passive and IPS is active. Both of them monitor the traffic. When they detect something malicious, when they find something suspicious, IDS only alerts, but IPS can also block the traffic. IPS can also be a single point of failure. And then we have network IDS and IPS, which are located to monitor all network traffic. Then we have a host IDS and IPS, which is located to monitor all traffic to and from a host. Then we have geofencing systems. These can identify the physical location of a user who is trying to access a system, and these grant access only if the user is in an authorized area. We can use this to limit access to a single office building, say, or even an entire country. So to go back to our question, here we are asking what can help us, to control the access based on the locations, that is the geographic borders. Though firewall, IDS and IPS can all be used, somehow configure the rules to do so. Geofencing system is the best solution in such cases, which can identify the location of a user who's trying to access the system. So the answer to today's question is geofencing,
Let's go to the next question.
which is not one of the steps to zero trust model. Automated rule based creation, identify the protect surface, mapping data flows, prioritize the external network. So to understand this question, we will have to understand what is a zero trust model and how is it different from the traditional environment. What is a zero trust security model? So, what happens in a traditional environment is that we generally have a security perimeter. That is, usually there is a firewall to separate the internet and the intranet. That is the internal network and the external network. And also, we assume that everything in the internal network is secure. It can access any device within the security perimeter. That is, in a traditional environment, everybody inside the network is trusted. Also, if you authenticate once to get to the security perimeter, you can access any resource within that perimeter. Zero trust model behaves in a very different way than the traditional environments. The slogan of zero trust model is to believe no one, assume no trust, and to check everything. Here we assume that any request would be malicious. We never grant trust implicitly, but it is always continuously evaluated. No one inside or outside the organization or the network is trusted unless the identification of that user has been thoroughly checked, and the assumption is that everyone can be compromised. So everyone's access should be verified. Here, access to resources are never based on location. Rather, the location is irrelevant when it comes to providing access. We don't trust any location or any device unless it is authenticated. And suppose say you need access to application A and your identity is verified, then you're given access only to the application A and not to the other applications in the environment or the network just because your identity was verified. There are 5 steps to a secure zero trust model. The first one is to identify all the resources, that is inventory. It is also to identify the protect surface, in the sense what you want to protect. The second step is to map the data flows of the sensitive data. This is to identify the transactional flows. The third step is to architect zero trust environments. Here we consider many mechanisms, security ones. For example, just in time access. Here you are given access only for a particular period of time, say for example 8 hours, and then you will have to re-authenticate. The next one is the just enough access. Here only the minimum privilege needed to carry out any request and only for a certain duration of the time is given to the user. No extra access is provided. The next security mechanism is encryption or tokenization. This is to decrease the sensitivity of the data and to reduce the attack surface. The next security mechanism is microsegmentation. Here, the workloads in a network or cloud environment or in a data center are isolated in order to limit the effect of malicious lateral movement. This is a method for managing network access between workloads in a data center or a cloud environment. This limits traffic based on the principle of least privilege. The basics of microsegmentation is to understand the traffic within the data center, that is east-west traffic flow, and the traffic to or from the internet, that is the north-south traffic flow, to provide protection. The fourth step to zero trust model is to create an automated rule base or to define dynamic policies. The access to any resource is determined by dynamic policy. This can be based on behavioral or environmental conditions. These access management systems can also check the device health. For example, if a device is up to date and has all the patches applied, if a device check fails or the user tries to access the resource from an unapproved or say unmanaged device, their request will be denied. Access policies can also vary based on adjustments to the sensitivity of the resources being accessed. The fifth and the last step to a secure zero trust model is continuous monitoring. SIEM and SOAR solutions, that is Security Information and Event Management System, that is SIEM solution, Security Orchestration, Automation and Response solution, that is SOAR solution. A combination of this can be used to get visibility into the network activity and the ability to respond instantaneously to any security issue. Now that we understand what is a zero trust model, let's try to understand the question and answer it. So it is asking which is not one of the steps to zero trust model. Option A, automated rule-based creation. Yes, this is a step to zero trust model. That is the second step where we are defining dynamic policies. So this is not the answer. Identify the protect surface. Yes, this is to inventory all the assets. Mapping data flows. Yes, we need to understand how the data flows so that we provide the necessary protection. Option D, prioritize the external network. No, this does not happen in zero trust model. Internal and external networks are treated equally and the same level of authentication process is presented to both of them. The access is never granted based on location in zero trust model. So the answer to the question is option D, prioritize the external network. You don't have to know the 5 steps to answer this question. Knowing how a zero trust model works is more than enough to answer this.
Let's go to the next question.
What type of controls is the SOC 1 Type 1 reports focused on? Integrity, privacy, financial, PII. So this question is mainly talking about SOC 1 Type 1 reports. To understand this question, to answer this, first we'll have to know what is SOC report, what are the types of SOC reports and what do they do. So that is what we'll discuss today. So SOC stands for Service Organization Control. This is used for auditing. SOC replaced SAS 70, that is Statement on Auditing Standards, in 2011, and SOC aligns with SSAE 16, which stands for Statement on Standards for Attestation Engagements. SSAE is managed by AICPA, which is American Institute of Certified Public Accountants. AICPA has 5 principles. We will talk about this a little later. SOC report has 3 categories, okay, 1, 2, and 3. That is SOC 1, SOC 2, SOC 3. And in this, again, there are subclasses saying type 1 and type 2. Everything like SOC 2, type 1, type 2, SOC 3, type 1, type 2. Type 1 and Type 2 are both evaluating the policies and procedures of an organization. So, what is the difference between these two reports, right? Type 1 is doing it for a specific time. Okay, it is just checking the policies if it is applied properly for that particular date whenever it is auditing. Type 2 evaluation is for a period of time. Type 1 is for just one day or that particular date. Type 2 is for a specific period of time. Usually, it evaluates the organization's controls over a period of at least 6 consecutive months. Okay. So, all you need to remember here is type 1 is for a single point in time, and type 2 is for a period of time, and it is usually 6 months. Okay. 6 consecutive months. So type 1 tells us that the controls are in place. Type 2 tells us that the controls are in place and also are actually working effectively over a period of time. So what is type 1 doing? It is only reviewing the design of controls and not how they are implemented and maintained, right? That is done by type 2. So type 1 reports are not like extremely useful, but type 2 is the one which really has a lot of data. Okay, now let's see what is SOC 1 report. This focuses strictly on the financial controls. Okay, SOC 1, you should always remember it is associated with the financial controls. It strictly evaluates an organization's financial statements, a service organization's controls that can impact a customer's financial statements. So, if a service organization that performs payroll or credit card processing, right, that would require a SOC 1 report. So, SOC 1 report is not related to the security personnel, remember that, okay? Now let's talk about SOC 2. SOC 2 is the one where the IT personnel will be interested in. SOC 2 evaluates the 5 trust principles of AICPA. Okay, the first trust principle is security. Security is where the system is protected against unauthorized access, both physically and logically. The next one is availability. This ensures that the system is available for operation and the data is available for use as agreed or committed in the contracts, policies, SLAs, right? The next one is the processing integrity. Here it ensures that the system processing is complete, accurate, valid and authorized. Okay, the next principle is confidentiality, where the system safeguards the information in the sense that which is called confidential or sensitive in accordance with the laws, regulations, policies, best practices. The next one is the privacy. Here it ensures that the system collects, uses and stores PII data in accordance with the organization's private policy and all the relevant laws and regulations. SOC 2 reports can include some of these or all of these principles, okay? But security principle is a mandatory one. This should be included. The other 4 are optional depending on what is the product, what is the service that is provided by the organization. The next SOC report is SOC 3. SOC 3 is very closely related to SOC 2 reports, but what happens in SOC 3? It removes all the details that are included in SOC 2 report. It actually has the same scope and cover the same principles. Okay, SOC 3 is mainly intended for public use. So it doesn't have a lot of data. It just demonstrates that the organization has follows all the 5 trust principles without disclosing all the sensitive or proprietary information. Okay, SOC 3 reports are commonly used for marketing as well, and it does not provide a lot of information, so security personnel will not be interested in this. It only says that the due diligence is performed by the organization or no. SOC 3 report, right, it provides the seal of approval for us, but no actual data regarding the security will be there in the SOC 3 reports. So by now you should have understood that SOC 2 is the one that security professionals are interested in, which provides a lot of useful information. SOC 2, especially when it is SOC 2 type 2. We talked about SOC 2 type 2 and type 1. Type 2 is over a period of time, usually 6 months, so it has a lot of data. It is talking about the effectiveness of the controls. So to summarize, in SOC there are 3 types, 1, 2, 3. In that there are subclasses again, type 1 and type 2. Type 1 is evaluating the policies and procedures only for a specific date, that is single point in time, and type 2 is for a period of time over 6 months, so it provides you more information. Type 1 is telling us if the control is implemented or not. Type 2 is telling us if the control is implemented and it is effectively working well. SOC 1 is reported to the financial statements, that is financial controls. SOC 2 is based on the 5 trust principles of AICPA: security, availability, processing integrity, confidentiality and privacy. It can include all the 5 principles or some of them, but security is the mandatory one. Okay, and it has a lot of information. SOC 3 is for the public. It is usually used as a marketing tool. It is a seal of approval, follows the same scope and principles as SOC 2 but eliminates all the sensitive information from the report. Now, to answer the question, it must be very easy because it is talking about SOC 1 Type 1. SOC 1 Type 1 and Type 2 both support financial. They are both focused strictly on the financial controls.
Let's go to the next question.
Who is responsible for getting an organization's legacy systems and applications connected with new cloud-based services that the organization's management has decided are crucial to customer service and offerings? Option A, Cloud Service Business Manager. Option B, Cloud Service User. Option C, Cloud Service Integrator. Option D, Cloud Service Administrator. So if you want to take a minute to understand the question and the options, you can pause the video here because next we will be discussing the answer. So the question says, who is responsible for getting an organization's legacy systems and applications connected with new cloud-based services? Option A is Cloud Service Business Manager. A Cloud Service Business Manager is responsible for overseeing the billing, auditing, and purchasing of cloud services. So option A is not our option. Cloud service user. A cloud service user is someone who consumes cloud services. So option B is not the answer. Option C is cloud service integrator. A cloud service integrator role is responsible for connecting and integrating existing services and applications with cloud-based services. So option C is our option because it talks about integrating. Here also you can see that legacy systems and applications connected to new cloud-based services. But let's see option D as well, what it says. Cloud Service Administrator. A Cloud Service Administrator is responsible for testing, monitoring, and securing cloud services as well as providing usage reporting and dealing with service problems. So option D, Cloud Service Admin, doesn't integrate legacy and cloud applications. So option C is our answer here.
Let's go to the next question.
Your organization is concerned with getting locked into a single cloud service provider and has flagged the ability to easily move between cloud service providers as a top priority. It also wants to save costs by reusing components. What cloud concept is your primary concern here? Option A, portability. Option B, resiliency. Option C, scalability. Option D, interoperability. So if you want to take a minute to understand the question and the options, please pause the video here because next we will be discussing the answer. So if you see the question here, it says that you don't want to get locked with a single cloud service provider and you should be able to move between cloud service providers easily, and also you need to save costs by reusing components, right? So the first option is portability. What is portability? Portability relates to the wholesale moving of services from one cloud service provider to another, but it does not necessarily relate to the reuse of components or services for other purposes. Okay. So this cannot be our answer because it also says, the question says that reusing components, right? The next option is resiliency. Resiliency is not an official concept within cloud computing. Although it is not an official concept, it certainly would be found throughout other topics such as elasticity, auto-scaling, and resource pooling. Not necessarily related to reuse of components or services for other purposes. So option B, resiliency, is not our answer here. Option C, scalability. Scalability pertains to changing resource allocations to a service to meet current demand, either upward or downward in scope. That is adding more servers or more power to the servers, or deleting the servers or reducing the power. So scalability is not our answer here. Last option is interoperability. Interoperability is the ability to easily move between cloud providers by either moving or reusing components and services. This can pertain to any cloud deployment model, and it gives organizations the ability to constantly evaluate costs and services as well as move their business to another cloud service provider as needed or desired. So the answer for this question is interoperability. So if you knew all the definitions and understood what they exactly mean, it would be easy for you to answer.
Let's go to the next question.
What is the security related concern for a PaaS solution? A virtual machine attack, web application security, data access and policies, system and resource isolation. You can pause the video here for a minute if you want to reread the question and the answers, because next we will be discussing the answer. To answer this question, we should know the different security considerations for all these cloud categories. The first one is infrastructure as a service security considerations. The first one in this is VM attacks. Cloud servers contain many VMs. These VMs may be active or offline, and regardless of being active or offline, are susceptible to attacks. Active VMs are vulnerable to all traditional attacks that can affect physical servers. Once a VM is compromised, VMs on the same physical server can attack each other because they share the same hardware and software resources, including memory, device drivers, storage, and hypervisor software. The next one is hypervisor attacks. Malicious hackers consider the hypervisor a potential target because of the greater control provided by lower layers in the system. Compromising the hypervisor enables control over the installed VMs, the physical system, and the hosted applications. Hyperjacking is installing a rogue hypervisor that can take complete control of a server. Examples of hyperjacking are Subware and Bluepill. Bluepill is a hypervisor rootkit attack. VM escape is done by crashing the guest operating system to get out of it and running an arbitrary code on the host operating system. This allows malicious VMs to take complete control of the host operating system. Next one is VM-based rootkits. These rootkits act by inserting a malicious hypervisor on the fly or modifying the installed hypervisor to gain control over the host workload. Virtual switch attacks. The virtual switch is vulnerable to a wide range of layer 2 attacks such as manipulation or modification of the virtual switch's configuration, VLANs and trust zones, and ARP tables. Denial of service attacks. DOS attacks in a virtual environment form a critical threat to VMs along with other dependent and associated services. Remember that not all DOS attacks are from external attackers. DOS attacks can be the direct result of misconfigurations at the hypervisor, which allows a single VM instance to consume and utilize all available resources. In the same manner as a DOS attack renders resources unavailable to users attempting to access them, misconfigurations at the hypervisor restrict any other VM running on the same physical machine. This prevents network hosts from functioning appropriately because of the resources being consumed and utilized by a single device. The next one is PaaS security considerations. System and resource isolation. PaaS tenants should not have shell access to the servers running their instances even when virtualized. The rationale behind this is to limit the chance and likelihood of configuration or system changes affecting multiple tenants. Where possible, administration facilities should be restricted to siloed containers to reduce this risk. Careful consideration should be given before access is provided to the underlying infrastructure hosting a PaaS instance. In enterprises, this may have less to do with malicious behavior and more to do with efficient cost control. It takes time and effort to undo tenant related fixes to their environments. The next one is user level permissions. Each instance of a service should have its own notion of user level entitlements, that is, permissions. If the instances share common policies, appropriate countermeasures and controls should be enabled by the cloud security professional to reduce authorization creep or the inheritance of permissions over time. The next one is user access management. User access management enables users to access IT services, resources, data, and other assets. Access management helps to protect the availability, integrity, and confidentiality of the assets and resources, ensuring that only those authorized to use or access these are permitted access. For user access management processes and controls to function effectively, a key emphasis is placed on the agreement, implementation of the rules, and organizational policies for access to data and assets. Some of the key components of user access management are authentication, authorization, administration, and intelligence. Authentication provides assurance and verification in real time as to the user being who they claim to be. Authorization determines the level of access to grant each user based on policies, roles, rules, and attributes. The principle of least privilege should always be applied. Administration is the ability to perform onboarding or changing account access on systems and applications. Intelligence requires collection, analysis, auditing, and reporting against rule based criteria, typically based on organizational policies. Note that user access management enables organizations to avail benefits across the areas of security, operational efficiencies, user administration, auditing, and reporting, along with other onboarding components. However, it can be difficult to implement for historical components or environments. Next one is malware, backdoors, and trojans. Traditionally, development and other teams create backdoors to enable administrative tasks to be performed. The challenge with these is that once backdoors are created, they provide a constant vector for attackers to target and potentially gain access to the relevant past resources. Once the attackers gain access through a backdoor, they can create additional backdoors while removing the legit backdoors, essentially holding the system's resources and associated services hostage. Code reviews and other software development lifecycle checks are essential to ensure that the likelihood of malware, backdoors, trojans, and other potentially harmful vectors is reduced significantly. Now let's see software as a service security considerations. The first one is data segregation. Multi-tenancy is one of the major characteristics of cloud computing. As a result of multi-tenancy, multiple users can store their data using the applications that SaaS provides. Within these architectures, the data of various users will reside at the same location or across multiple locations and sites. With the appropriate permissions or using attack methods, the data of customers may become visible or possible to access. Typically, in SaaS environments, this can be achieved by exploiting code vulnerabilities or injecting code within the SaaS application. If the application executes this code without verification, there is a high potential of success for the attacker to access or view other customers or tenants' data. A SaaS model should therefore ensure a clear segregation for users' data. The segregation must be ensured not only at the physical level but also at the application level. The service should be intelligent enough to segregate the data from different users. A malicious user can use application vulnerabilities to handcraft parameters that bypass security checks and access sensitive data of other tenants. One is data access policies. While allowing and reviewing access to customer data, the key aspect to structuring a measurable and scalable approach begins with the correct identification, customization, implementation, and repeated assessments of the security policies for accessing data. The challenge associated with this is to map existing security policies, processes, and standards to meet and match the policies that the cloud service provider enforces. This may mean revising existing internal policies or adopting new practices whereby users can only access data and resources relevant to their job, function, and role. The challenge from the cloud service provider perspective is to offer a solution and service that is flexible enough to incorporate the specific organizational policies put forward by the organization while also being positioned to provide a boundary and segregation among the multiple organizations and customers within a single cloud environment. The next one is web application security. Because SaaS resources are required to be always on and availability disruptions kept at a minimum, security vulnerabilities within the web applications carry significant risk and potential impact for the enterprise. Given the large volume of shared and co-located tenants within the SaaS environments, if a vulnerability is exploited, both the cloud customer and the service provider may experience bad consequences. Just like in traditional environment, cloud services also rely on a robust, hardened, and regularly assessed web application to deliver services to its users. The fundamental difference between cloud-based services versus traditional web applications is their footprint and the attack surface they will present. The failure to carry out web application security assessments and code reviews may result in unauthorized access, corruption, or other integrity issues affecting the data, along with a loss of availability. Web applications introduce new and specific security risks that may not be defended against by traditional network security solutions like firewalls, IDS, IPS, and so on. The nature and manner in which web application vulnerabilities and exploits operate may not be identified or may appear legitimate to the network security devices designed for non cloud architectures. So, with this knowledge, it is very easy to answer this question. What is the security related concern for a past solution? The first option, virtual machine attacks, is not true because this is related to infrastructure as a service solution. The next one is web application security. It is related to SaaS, data access and policies, again related to SaaS solution. So the answer is option D, system and resource isolation, which is a past concern.
Let's go to the next question.
What are the 5 trust service principles? Option A, security, auditability, processing integrity, confidentiality, and privacy. Option B, security, availability, customer integrity, confidentiality, and privacy. Option C, security, availability, processing integrity, confidentiality, and non-repudiation. Option D, security, availability, processing integrity, confidentiality, and privacy. If you need a minute to read the question and the options again, please pause the video here because next we will be discussing the answer. To answer this question, we should be aware of AICPA's 5 trust service principles. AICPA stands for American Institute of Certified Public Accountants. The first one is security. The system is protected both physically and logically against unauthorized access and unauthorized disclosure of information. As confidentiality. The system safeguards information designated as confidential or sensitive in accordance with laws, regulations, and best practices. Privacy. The system collects, uses, and stores PII in accordance with the organization's stated privacy policy and all relevant laws and regulations. Integrity. System processing is complete, accurate, valid, and authorized. Availability. The system is available for operation and data is available for use as committed and agreed upon in SLAs or contracts. So SOC 2 and SOC 3 reports make use of these 5 trust service principles. SOC is Service Organization Controls. SOC 2 reports evaluate an organization based on AICPA's 5 trust service principles, that is security, availability, processing integrity, confidentiality, and privacy. SOC 2 reports can actually include some or all of the 5 trust service principles. The security service principle is the mandatory one. It must always be included, but the other 4, that is confidentiality, privacy, processing integrity, and availability are optional depending on the product or service provided by the organization. SOC 2 reports for cloud providers generally include all five principles as all are applicable to the type of services they provide. SOC 3 reports are closely related to SOC 2 reports. They share a common scope and cover the same principles. However, SOC 3 reports remove many of the details that SOC 2 reports include. They are intended to be publicly available reports that indicate whether an organization has demonstrated each of the five trust principles without disclosing anything sensitive or proprietary. SOC 3 reports are commonly used for marketing purposes, and you may also use them as an initial due diligence check of a potential cloud provider. So the answer for today's question is option D, that is security, availability, processing integrity, confidentiality, and privacy. Thank you so much for watching. I'll see you in the next video. Until then, take care of yourselves. Bye bye.